Good day. It's May the 15th today, and it's a learning and development day. Today we're going to do something completely different. I'm not sure why my chat box was not doing anything. Let's say a good day again. See if it's working. Yes, now it's working. Apparently. So what are we going to do today? Today we are preparing for the renewal of the AZ204 certification. I need to refresh my certification. You need to do that every year, so this is the time for me to refresh my memory there and see what are the current topics that we need to address to fix the renewal. Let's start the show. So welcome back. It's going to be a long day, I think, a long stream. So we're just going to be a little bit chill and just learn with me is what I would say today. Obviously, I'm not going to share the renewal of this certification itself because that's restricted to share on screen. But what I'm going to do is go through MS Learn and see what are the topics for today. So let's go to the main screen here. I'm not using my VM today. So let's pick another tab there, maybe drag it out. So what do we need to do? We need to go to learn.microsoft.com, microsoft.com. Maybe sign in there. Build is coming up next week, May 21st. Let's sign in here. Should allow me to sign in by my existing account. No, let's put in the secrets here. That should be it. So go to my profile here and then go to certifications. Thank you for following. Oh, rating even. TBD Gamer. How are you today? 30 viewers of TBD Gamer. What were you up to today? What did you do there? Did you just wrap up your stream? So what I'm going to do today is going to work on my certifications. I need to renew that. Credentials. Currently building an agile planning tool like Jira. Just doing something brainstorming today. Try to figure out workflows and building a mind map. That's a challenge. Is that something you do to build a new product or for school? Or what is the plan there? As you can see, my Azure Developer Associate certification needs to be renewed. Let's click on that. Let's see what it's bringing us. So these are the skills measured by a renewal assessment. The plan is to treat it like I'm building a full product. And if it works out, it works out. And if not, I open source a lot. So I stream to share the journey. Basically what I also do a little bit. Renew your Microsoft certification for free. So these are all the items in the collection that are, if you can see already, did some of them. Oh, I did a lot of them, but I probably need to refresh my memory on those as well. So probably will do that again. So let's start from the top here. So the plan is to just go through all these modules that we, maybe I should, oh, it's already there. Stick this somewhere. Let's make that copy of that for my notes. Let's create a new page. AZ204 renewal. And I can put the link in the chat as well. So I'm not sure how that looks if you haven't already done so, but there's my Ring doorbell ringing. Let's shut that down as well. So what I'm going to do is just go through all these items here, and I'm not sure how much time that needs. Oh, it says like 5 hours. In the middle, I will have like some hour of dinner, and every 2 hours some coffee things and drinking, and so little breaks to pee and do other things that you need to do. If you want to follow along but you don't want to be here all day, it would be good to either on Twitch follow me here so that you can get back, and or on YouTube subscribe, hit the bell. I won't be logging off and on again every 2 hours, but it just will be an 8-hour stream. And yeah, just continue streaming, including the breaks. Why is there a dog barking outside? I don't know. So let's explore, let's blow this up a little bit so it's easier to read. Explore Azure functions. This is the main intro page. Learn the objectives. Explain functional differences between Azure functions, Azure Logic Apps, and web jobs. Describe Azure functions hosting plan options. Describe how Azure functions scale to meet the business needs. And we have the introduction. Discover functions. Compare with other options. Scale functions and knowledge check, and then summary. Let's get in there. It's now 3:15 my place PM. Let's see, we'll probably be here until at least 10 PM or maybe 12 PM, depending on how fast we are going. That makes it a little bit smaller. Azure Functions let you develop serverless applications on the Microsoft Azure. You can write just the code you need for the problem at hand, without worrying about a whole application or infrastructure to run it. After completing module, you'll be able to explain functional differences between Azure Functions and Azure Logic Apps, the same thing as the previous page. And web jobs, describe Azure Functions, hosting plan options, and describe Azure Functions how to scale Azure Functions to meet the business needs. Continue. I said continue. Discover Azure Functions. Azure Functions is a serverless solution that allows you to write less code, maintain less infrastructure, and save costs instead of worrying about deploying and maintaining servers. And you don't have to mind my Dutch dialect here. The cloud infrastructure provides all the up-to-date resources needed to keep your applications running. We often build systems to react to a series of critical events, whether you're building a web API or responding to database changes, processing IoT data streams, or even managing message queues. Every application needs a way to run some code as these events occur. Azure Functions support triggers, which are ways to start execution of your code, and bindings, which are ways to simplify coding for input and output data. There are other integration automation services in Azure, and they all can solve integration problems and automate business processes. They can all define input, actions, conditions, and output. Let's compare Azure Functions and Azure Logic Apps. Both Functions and Logic Apps are Azure services that enable serverless workloads. Azure Functions is a serverless compute service, whereas Azure Logic Apps is a serverless workflow integration platform. Both can create complex orchestrations. An orchestration is a collection of functions or steps called actions in Logic Apps that are executed to accomplish a complex task. For Azure Functions, you develop orchestrations by writing code and using the durable function extensions. For Logic Apps, you create orchestrations by using the GUI or edited configuration files. So the way I read it, Azure Functions is more like in the backend, and the Logic Apps is created by a GUI or editing configuration files. Apparently you can do that manually. If you have, by the way, feedback and you want to share information, just put it in the chat and let's make this an interactive session so everyone can join in. Let's see, for Azure Functions, you develop orchestrations by writing code and using durable function extension, using the durable functions extension. Is that the link? For Logic Apps, you create orchestration by using GUI. This was, we already were reading that. The following table lists some of the key differences between Azure Functions and Logic Apps. Let's quickly have a look at this one. Durable functions extension. That's not about the extension, that's about durable functions. Durable functions is a feature Azure Functions lets you write stateful functions in a serverless compute environment. The extension lets you define stateful workflow by writing orchestrator functions and stateful entities. By writing entity functions using the Azure Functions programming model, behind the scenes, the extension manages state checkpoints and restarts for you, allowing you to focus on the business logic. Supported languages, a lot of language here. .NET C#, F#, JavaScript, TypeScript, V3, V4, Python, Python V2 programming model, PowerShell, and Java. Like Azure Functions, there are templates to help you develop durable functions using VStudio, VStudio Code, and Azure Portal. Application patterns. Well, let's go back at first to the other page, this one. Do the compare development. Azure Functions code first, Logic Apps designer first, because that's basically an app. Connectivity, about a dozen built-in binding types, write code to custom bindings. Large collection of connectors, enterprise integration pack, and B2B scenarios. Build custom connectors. I think that also depends on the licenses you have in place. You're very weak on the cloud stuff. I've mainly done on-prem stuff my entire career. That's what TBD Gamer says. That means that you actually need to change your pattern there, because the cloud is the future already, I would say. And you can do a lot of your things on-prem by just register to Azure and get your free credits going. And it's actually not that expensive. I run maybe 10 websites and 2 VMs for my live streams. And that's not even getting more than the $150 every month. And that's part of my Fish Studio subscription. Actions. Each activity is an Azure function. Written code, write code for activity functions. And in Logic apps, actions are a large collection of ready-made actions. These, I think, kind of prepared is also what you see in, I think, in UiPath. Monitoring Azure Application Insights, or Logic apps have the Azure portal, Azure Monitor Logs. Management, REST API for Studio for Azure Functions, Azure Portal, REST API for PowerShell for Studio for Logic apps. The execution context runs in Azure or locally. The Logic apps it runs in Azure locally or on premises. I wonder what the difference in this case locally means. Compare functions and web jobs. Just like Azure Functions, Azure Web App Services serves web jobs with the Web Jobs SDK is a code-first integration service that's designed for developers. Both are built on Azure App Service and support features such as source control integration, authentication, and monitoring with application insights integration. Azure Functions is built on Web Jobs SDK, so basically that's on top. Let's make a note of that. Azure Functions on top of Web Jobs SDK. So it shares many of the same event triggers, and the monitoring tool is Application Insights, monitoring application. If I can type Application Insights. So it shares many of the same event triggers and connections to other user services. Here are some factors to consider when you're choosing between Azure Functions and Web Jobs with the Web Job SDK. The functions are serverless app model with automatic scaling, while the Web Jobs are not scalable in the serverless app model. Development test in the browser, functions yes, Web Jobs no. Pay-per-use pricing, functions yes, Web Jobs no. Integration with Logic apps, functions yes, Web Jobs no. I think what this means is that you can use your Logic apps to call Azure Functions, I think as a connector. Trigger events for functions, that is a timer, Web Jobs timer, functions Azure Storage Queues and Blobs, both sides, Azure Service Bus Queues, both sides, topics, Azure Cosmos DB, Azure Event Hubs, same thing both sides. HTTP webhook, that's how you can trigger them. The file system on the web jobs and the Azure Event Grid on functions. Azure Functions offer more developer productivity than Azure App Service web jobs does. It also offers more options for programming languages, developer environments, Azure service integration, and pricing. For most scenarios, it's the best choice. Question is, how are they pricing web jobs in this case? I don't know. Compare Azure Functions hosting options. Azure Function hosting options. When you create a function app in Azure, you must choose a hosting plan for your application, for your app. There are 3 basic hosting plans available for Azure Functions. There's consumption plan. Let's make a note of that. Consumption plan. Premium plan. And app service plan. That's dedicated. All hosting plans are GA, general available, on both Linux and Windows. All plans GA for Linux and Windows. The hosting plan you choose dictates the following behaviors. How the function app is scaled, the resource available for each function app instance, support for advanced functionality such as Azure Virtual Network connectivity. The following is a summary of the benefits of the 3 main hosting plans. So the consumption plan, this is the default hosting plan. It scales automatically and you only pay for compute resources when your functions are running. Instances of the functions host are dynamically added and removed based on the number of incoming events. The premium plan automatically scales based on the demand using pre-warmed workers, which run applications with no delay after being idle, runs on more powerful instances, and connects to the virtual networks. So let's make a note of that as well. Consumption plan. Next time, maybe I should pick a way to also share this with the viewers, or well, if everyone even could add their own comments, maybe. Maybe a loop component or something like that. Automatically scale-based pre-warm, that's what we already had been looking at. Run your functions with an app service plan at regular app service plan rates. Best for long-running scenarios where durable functions can't be used. So if you have a scenario where you can't use the durable functions, then it would be good to go for the dedicated plan. Apparently, and I guess that will also be more expensive. There are two other hosting options which provide the highest amount of control and isolations in which to run your function apps. It's the hosting options ASE. I wonder why they say, well, you have like 3, and by the way, there are 2 more hosting options. Oh, it's a hosting options. That's the application service environment. Is an app service feature that provides fully isolated and dedicated environment for securely running app service apps at high scale. The reason why I note this down as well is because if you use as many ways to do things, your memory will remember it more easy. So if you like reading and speaking it, read it out loud, writing it usually, it's even better to do it by hand, but I do have my pen here, but yeah, that's not what I'm going to use. I'm using my OneNote there on my other screen. The other option is Kubernetes. Kubernetes. I'm not sure if that's the right pronunciation. Kubernetes provides a fully isolated and dedicated environment running on top of the Kubernetes platform, direct or through Azure Arc. So these are the hosting models. Hosting. Kubernetes. The other one is application app service environment. Then the hosting plans and scalability. I wonder why that's all done separately. Because there are definitely going to be questions around that, I think. That was the hosting plan scaling. The following table compares the scaling behaviors of the various hosting plans. Maximum instances given per function app consumption or per plan premium dedicated basis, unless otherwise indicated. So you have the consumption plans, event driven. That's interesting. The max instances on the consumption plan is Windows 200, is higher than on the premium plan. So you run less on a higher plan. Event driven, scale out automatically even during periods of a high load. Azure functions infrastructure scales CPU and memory resources by adding more instances of the function host based on the number of incoming trigger events. So that means consumption plan is event driven, and it's Windows 200, Linux 100. Then premium plan is also event driven, scale out automatically even during periods of high load. Azure functions infrastructure scales CPU and memory resources by adding more instances of the functions host based on the number of events that its functions are triggered on. That's the difference between this one and this one. Consumption plans is based on the number of incoming trigger events, and premium plans is based on the number of events that its functions are triggered on. Not sure what the difference between that is. Based on the number of incoming trigger events, or based on the number of events that its functions are triggered on. Interesting. Dedicated plan is manual or auto scale. That is dedicated. Manual auto scale, and the numbers are 10 to 20. 10 to 20. Then the ASE is also manual auto scale. It's the application server environment. Surface environment, I should say. These numbers are much higher, like hundreds. Kubernetes, event-driven autoscale for Kubernetes clusters using KEDA. My guess is that that means like Kubernetes event-driven something. Autoscaling. Kubernetes event-driven autoscaling. That's a good guess. Varies by the cluster. Numbers vary by the cluster. Maximum scale out can vary by region and hosting plan. For more information, visit the premium plan article and the app serves plan limits. Let's have a quick look. So I'm in the Netherlands, that's Western Europe probably. This one, that has 100 and 100. Windows and Linux. And US, West US. How about East US? That's where Microsoft is. It's also 100 to 100, so we are on the top notch of the numbers there. 100 to 100 is the max for all, I think. Yeah. And the other one, app service plan limits. Azure subscription, service limits, quotas and constraints. Oh, that's a big list. That's even extending, so let's expand this. Is that on screen? Yes, that's visible on screen. The app service plan 10 per region. Free and shared 100, 100, 100 and 100. For each of the resource groups. I think if you want to start for free, this is the interesting part there. One free Linux app service plan per region. Does that mean you have like 10 windows? Or like 9 windows? Or maybe 10 windows and 1 Linux app service? Free. The downside, I think, is usually the custom domain. However, the custom domain is not available for the free version. That means you have to stick to the Azure URLs. But if you're just testing that, would be okay. But if you want to go public, then you probably want to attach it to your own custom domain. And in that case, it's not going to work for free. Let's see if the shared one has custom domains. Yeah, and do 5. But the downside of the shared one, that's that the certificates are not supported. That's probably also a bummer if you want to go put it on public things. That means you almost immediately drop back to basic, because that allows you to have either both your custom domain and also certificates, because you need your certificates. That's this one, custom domain single SSL support. That's your certificates, otherwise you're stuck to azurewebsites.net. Again, if you're just testing, that would be okay. I think my personal plans are all on, I think, basic. Like my website, this one, www.softtestingsoftware. I think this runs on a basic plan. So I have my custom domain, and I also have like the certificate in here. That's generated by Azure, I think. The DigiCert. What's the name? That will be refreshed every couple of weeks or months. I don't know. Let's see if the broadcast is. Why is it not in here? The live session is not in here. Interesting. That means it's still in the cache. We're looking at the cache because I put some cache on there. Yeah, that was the if you want to read all about the subscription limits, that's a separate page with a lot of information there. App service plan limits, function app timeout duration, the function timeout property. Copy that and put that in my notes. The function timeout property is in the host.json file. The host.json project file specifies the timeout duration for functions in the function app. The properties applies specifically to function executions. After the trigger starts function execution, the function needs to return respond within the timeout duration. The following table shows the default and the maximum values. So if your consumption, let's make a note of that again. So I have them all together. Timeout for consumption is 5 default, max 10. Premium, copy and paste it there, is default 30. Is that seconds, minutes? What is it? Minutes. Minutes. Premium 30 minutes and unlimited. And then dedicated is the same, 30 minutes and unlimited. Storage account requirements. On any plan, function app requires a general Azure storage account, which supports Azure Blob, queue files, table storage. This is because functions rely on Azure storage for operations such as managing triggers and logging function executions, but some storage accounts don't support queues and tables. So it requires a general Azure storage account. I think that's also needed for the application insights. The same storage accounts used by your function app can also be used by your triggers and bindings to store your application data. However, for storage intensive operations, you should use a separate storage account. But that's more like performance wise. Next unit, scale Azure functions. In the consumption and premium plans, Azure Functions scales CPU and memory resources by adding more instances of the functions host. The number of instances is determined on the number of events that trigger a function. Each instance of the functions host in the consumption plan is limited to 1.5 gig of memory. That's consumption, and 1 CPU. That's 1.5 gig and 1 CPU. For the consumption, for the consumption plan, an instance of the host is the entire function app, meaning that all functions within the function app share resource within an instance and scale at the same time. Function apps that share the same consumption plan scale independently. In the premium plan, the size determines the availability of the memory and CPU. For all apps that in that plan on that instance. Function code files are stored on Azure File Shares on the function's main storage account. When you delete the main storage account of the function app, the function code files are deleted and can't be recovered. That's important to know. Runtime scaling. Azure Functions use a component called Scale Controller to monitor the rate of the events and determine whether to scale out or scale in. The Scale Controller uses heuristic for each trigger type. For example, when you are using an Azure queue storage trigger, it scales based on the queue length and the age of the oldest queue message. The unit of scale of Azure Functions is in the Functions app. The unit of scale. When the function app is scaled out, more resources are allocated to run multiple instances of the Azure Functions host. Conversely, as compute demand is reduced, the Scale Controller removes function host instances. The number of instances is eventually scaled into 0 when no functions are running within the Functions app. The unit of scale for Azure Functions is the Functions app, the Function app. So what you see here is monitoring events, Scale Controller, and the Scale Controller determines based on the number of events or the delay of the events, I guess, and creates function hosts accordingly, and that will process the events. After your function has been idle for a number of minutes, the platform may scale the number of instances with your application runs into 0. That's what's already mentioned here as well. The next request has the added latency of scaling from 0 to 1. This latency is referred to as a cold start. Well, that depended on the plan that you are using, is what we saw earlier. Scaling behavior. Scaling can vary on many factors and scale differently based on the trigger and language selected. There are a few intricacies of scaling behaviors to be aware of. Maximum instances. A single function app can only scale out to a maximum of 200 instances. I think that depends on the list. For consumption plans, 200. I think the premium was 100. Premium plan was 100. To a maximum of 200. Well, yeah, if you take into account, depending on which plan you are using, a single instance may process more than one message or request at a time. One message or request at a time though, so there isn't a set limit on the number of concurrent executions. A new instance rate. For HTTP triggers, new instances are allocated at most once per second. Non-HTTP triggers, new instances are allocated at most every 30 seconds. That's an important thing to know, I think. Limit scale out. You may wish to restrict the maximum number of instances an app is used to scale out. Is most common for cases where the downstream component, like a database, has limited throughput. By default, consumption plan functions scale out to as many as 200 instances, and premium plan scales out to 100. What we just found out again. You can specify a lower maximum for a specific app by modifying the function app scale limit. Another attribute that might be important. The function app scale limit can be set to 0 or null. To set to 0 or null for unrestricted, or valid value between 1 and the application maximum. So if you have this one with 200 instances, then it could be set to somewhere between 1 and 200. But if you have the premium, then it can be set to 1 and 100. Knowledge check. Okay, everyone in the chat room, bring in your answers. Check your knowledge. Which of the following Azure Functions hosting plans is best? Predictive scaling and cost are required. Which of the following Azure Functions hosting plans is best when predictive scaling and costs are required? Is that Functions Premium plan, the dedicated plan, or consumption plan. Bring in your votes. An organization wants to implement a serverless workflow to solve a business problem. One of the requirements the solution needs to use a designer first, declarative development model. Which of the choices meets the requirements? So the first one, I would say predictive scaling and cost. So you want to know the costs up front. With the app service plan dedicated, is for long running. So it would be a wild guess for me. I think it's predictive scaling. The consumption plan is just on demand. There's nothing to predict. Dedicated is fully separated. So I would say functions premium plan. The other one, which of the choices meets the requirements? One of the requirements is need to be user designed. Declarative development. The designer is the Logic apps, I think. Oh, the first one is yeah, congratulations, there's an error in there. Let's go back, review answers. The premium plan does support scaling, but is not predictive. Let's make a note of that. And the dedicated plan runs in app servers with support settings, auto-scaling rules based on predictive usage. Dedicated plan runs in the app servers with support, runs in app service which supports setting auto-scaling. Oh, but that's a complete, yeah. That's the app service plan. That's the tricky thing there, because the plan is not called dedicated plan. The plan is called the app service plan. So it's basically a trick question there. The other one, organization wants to implement serverless workflow to solve a business. One of the requirements solution needs a use design first declarative development model. That's a mouthful. And the Azure Logic apps enable serverless workloads and use a designer first declarative development model. That's basically repeating the question, but I think it should say that it's GUI based. And that's the one for Azure Logic apps. I don't have a section on that. Azure Logic apps. It's interesting because the area is about functions and you get a question about logic apps. So let's go back quickly for the predictive. Also not mentioned here. So there's nothing about prediction here. So why are you asking something what's not explained? Predictive. Oh. Predict function, that's not related to that either. Well, okay, let's take that for a given then, but it's not in the documentation here. So that was this Azure function hosting plan, predictive scaling and costs required. That's the actually dedicated plan. And this was the Azure Logic Apps. That's the right one. Continue. So like these three questions that makes the certification difficult because you often get things in a different wording. All units complete. Complete model. Yay! We have the option to implement. That's taking a little bit too long probably for doing that right now. I can see that I did something there. Let's make that. Note here for additional training resources. That's probably giving everything. The logic apps. This one is completed. Implement feature flags in the cloud native ASP.NET Core microservices app. I'm not sure if that's related to Azure Functions. Serverless computing. Okay, that's the first one. Azure Functions. Let's see if we refresh this, maybe changing things. %, complete. Let's go into develop Azure Functions. Change nodes, develop Azure Functions. New notes. Develop Azure functions. I think we are now going to actually do some things here. Learning objectives, I should say, not objections. Objectives explain the key components of a function and how they are structured. Create triggers and bindings to control when a function runs and where the output is directed. Connect a function to services in Azure. Create a function by using Visual Studio Code and the Azure Function Core tools. Prereqs. You should have been familiar with the developer concepts and technologies, terminologies, and understanding of cloud computing and some experience with the Azure portal. Module is part of the learning path AZ204. That's basically what we are working on right now. And it's the parts: introduction, explore functions development, create triggers and binding, Azure services, exercise, knowledge check, and summary. So let's go start this. Introduction is probably repeating the same thing again. Explain the key components of a function and how they are structured. Create triggers and binding controls when a function runs and where the output is directed. Connect a function to services in Azure. Create a function by using Visual Studio Code and the Azure Functions Core tools. Okay, continue. Make it a little bit smaller so that it fits on the screen. Explore Azure Functions development. A function contains two important pieces: your code, which can be written in various languages, and some config. Function JSON file, that's the config file. I think that had been a question previous years as well. Config file. Function.json. For compiled languages, this config file is generated automatically from annotations in your code. For scripting languages, you must provide the config yourself. The function JSON defines the function's trigger, bindings, and configuration settings. Every function has one and only one trigger. That's not much to go for. But for separation, I can understand why that is. The runtime uses this config file to determine the events to monitor and how to pass data into return data from a function execution. Following is an example of a function JSON file. It's not disabled and there's one binding type, incoming with a param, and some things that are left out. The bindings property is where the configuration configure both triggers and bindings. Each binding shares a few common settings, and some settings are specific to the particular type of binding. Every binding requires the following settings: type of the binding, the direction, in or out, and a specific name. The name is used for the bound data in the function, for example, myQ. Type, direction, and the name. Function app. Function app provides an execution context in Azure in which your functions run. As such, it's the unit of deployment and management for your functions. Function app is composed of one or more individual functions that are managed, deployed, and scaled together. All of the functions in the function app share the same price plan. So all of the functions in the function app share the same pricing plan, deployment method, and runtime version. Think of function app as a way to organize and collectively manage your functions. In functions 2.x, all functions in the function app must be authored in the same language. In the previous version of the Azure Functions runtime, this was not required. So in the previous version, you were allowed to mix and match languages. I actually thought that was a nice thing. What do you think about it? That's no longer mixed languages. Folder structure. The code for all the functions in the specific function app is located in the root project folder that contains a host configuration file, the host.json. So that's host.json, host configuration file. Contains runtime specific configurations and is in the root folder of the function app. That's mentioned twice there. A bin folder contains a package and other libraries that the function app requires. Specific folder structure required by the function app depends on the language. C# compiled, C# script. That's basically a runtime, I think. F#, Java, JavaScript, and Python. Local development environments. Functions make it easy to use a favorite code editor and development tools to create and test functions on your local computer. Your local functions can connect to live Azure services, and you can debug them on your local computer using the full functions runtime. The way in which you develop functions. White Panther just raided the channel with 88 viewers. Thank you, White Panther. How are you doing today? And what are you up to? What did you do today? Did you just finish your live stream? Obviously, otherwise you wouldn't have like 88 viewers. I'm writing some code trying to hack some lighthouse scores. Building some kind of weird game. That's super cool. I need to keep track of everyone who's raiding today. And check out his channels. Thanks for the follow, Gamer W. That's super cool. Thanks for following White Panther. I'm crazy now. Everyone is starting to follow. My notification, my follow notification is still showing no input on the text is what I see. Did you see the same thing there? I need to check that, I think, on the notification thing of stream elements. Local development environments. Functions make it easy to use for the favorite code editor and development tools to create and test functions on your local computer. This is what we already read about, I think. The full functions runtime on your local machine. So you basically could do it all locally. Next unit, create triggers and bindings. Do not mix local development with portal development in the same functions app. When you create and publish functions from your local app, you should not try to maintain and modify project code in the portal. My guess is will overwrite the code on the portal, and that's nice if your production code will be overwritten by your local attempts there. Create triggers and bindings. Triggers cause the function to run, and that's why we call it a trigger. A trigger defines how a function is invoked, and a function must have exactly one trigger. That was we saw in the previous one as well. Binding to a function, let's see, where are we? Triggers have associated data, which is often provided as the payload of the function. The payload of the function, that's a nice term. Binding to a function is a way of declarative connecting any resource. By the way, I haven't explained to the new viewers what we are doing here. We are preparing for the renewal of the AZ204 certification, the Azure certification. That's basically this one. It's going to expire in 73 days for me, July the 28th, so I need to renew it. And for that, there are this year's new topics, or maybe they are not new, but at least they need to be refreshed by the renewal assessment. And those are like the topics, so Azure Functions, development, implement, and all these things that you see over here. There's a collection of learning things. And we are going through all of these today in a marathon session, about 8 hours. So if you haven't already done so, follow on YouTube or Twitch or whatever if you want to join in later as well, after the breaks and things. But we're now continuing up to the next coffee break. I still have my water for hydration. Let's see, where were we? The payload of the function. Binding to a function is a way of declarative connecting another resource to the function. Binding may be connected as input bindings, output bindings, or both. Data from bindings is provided to the function as parameters. I think we just saw that in the JSON as well. You can mix and match different bindings to suit your needs. Bindings are optional, and the function may have one or multiple input or output bindings. So you can have one trigger but multiple bindings. Triggers and bindings let you avoid hard-coding access to the other services. Your function receives data, for example, the content of the queue of a queue message in function parameters. You send data, for example, to create a queue message by using the return value of the function. That's interesting. Trigger and binding definitions. Trigger and bindings are defined differently depending on the development language. So if you have a C# class library decorating methods and parameters with C# attributes, Java decorate methods and parameters with Java annotations. I think it's all the same thing but different naming. JavaScript, PowerShell, Python, and TypeScript update function JSON schema. For languages that rely on function JSON, the portal provides UI for adding bindings in the integration tab. You can also edit the file directly in the portal in the code plus test tab of your function. That's in the portal. Yeah, that's indeed in the portal. Looking at that before, maybe we're doing that in a minute as well. I don't know. In .NET and Java. .NET and Java, the parameter defines the data type for input data. For instance, use string to bind to a text of a queue trigger, a byte array to read as binary, and a custom type to deserialize to an object. Since .NET class library functions and Java's function don't rely on functions JSON for binding definitions, they can't be created and edited in the portal. They can't be created and edited in the portal. C# portal editing is based on C# script, which uses the function JSON instead of the attributes. For languages that are dynamically typed, such as JavaScript, use the data type property in the functions. Function JSON, this is function JSON, the data type For example, to read the content of the HTTP request in binary format, you set data type to binary, and the type is trigger, HTTP trigger, name request and direction is incoming in. Other options for data type are stream and string, binding directions. All triggers and bindings have the direction property in the function JSON. That's this one. One in and we have one out in this case. For triggers, the direction is always in. That's basically the idea of trigger, because the function gets triggered by something that's coming in. Input and output bindings use in and out. Some bindings support special direction in-out, that's both. If you use in-out, the only advanced editor is available via the integrate tab in the portal. When you use attributes in a class library, the configured triggers and bindings, the direction is provided in an attribute constructor or inferred from the parameter type. Azure functions trigger binding example. Show what's happening here. Suppose you want to write a new role to Azure Table Storage. When a new message appears in the Azure Queue Storage, the scenario can be implemented using Azure Queue Storage trigger and the Azure Table Storage output binding. Here's the function JSON for the scenario. So we have bindings, and the one queue trigger is incoming, name is order, and the queue name is my queue items, and the connection is used my storage account application setting. And we have a binding to a table, outgoing, name return, table name out table, my table storage account application setting. The first element in the bindings array, let's keep that inside, is the queue storage trigger. The type of direction provides the type and direction properties identify the trigger. The name property identifies the function parameter that receives the queue message content. The name of the queue to monitor is the queue name. That's what we just went over. And the connection string is the app setting identified by connection. You can make it up yourself. You just do the logical thinking there. Second element in the bindings array is the Azure Table Storage output binding. The type and direction properties identify the binding. The name property specifies the function provides a new table. How the function provides a new table row. In this case, by using the function return value. The name of the table is in the table name, and the connection string is in the connection. C# script example. Here's C# script code that works with the trigger and binding. Notice that the name of the parameter that provides a queue message contains is order. This name is required because the name property in the value of function JSON is order. That's this one. I assume this is matching the other one. Order, that's this one. From an incoming queue message that is a JSON object, add fields and write table storage method return value creates a new row in the table storage. The JavaScript example. Same function JSON file can be used with the JavaScript function, where it exports function context and order, order partition key orders, and the row key is random generated. That's in this case a new one. A math random substring something. Let's see, class library example. In class library, the same trigger and binding information queue and table name storage account function parameters for input output is provided by the attribute. That's these things. Where were we? The class library, same trigger, binding information queue, table storage functions provided by the attribute instead of the function JSON file. Additional resources: Azure Blob Storage, binding for Azure functions, Cosmos DB, time trigger, and Azure functions. Next unit, connect functions to Azure services. Wonder if we do have an exercise here. Wondering if we can use the black box, the sandbox, or that we need to use the Azure subscription for that. Connect functions to Azure services. Your function project references connection information by name, its configuration. Your function project references connection information by name from its configuration provider. It doesn't directly accept the connection details, allowing them to change across environments. For example, a trigger definition might include a connection property, but you can't set the connection string directly in the function JSON. Instead, you would set the connection to the name of the environment variable that contains the connection string. The default configuration provider uses environment variables that are set in application settings. When running the Azure Function Service, or the local settings file when developed locally. Configure an identity-based connection. Some connection in Azure functions are configured to use the identity instead of a secret. Support depends on the extension using the connection. In some cases, the connection string may still be required in the functions, even though the service to which you're connecting supports identity-based connections. Identity-based connections are not supported within durable functions. Let's make a note of that, just to remember it. As we mentioned before, you better remembering things if you put things through multiple ways of doing things, like reading, writing, and doing, obviously, and we are doing here as well, I hope. When hosted in Azure Function Service, identity-based connections use a managed identity. The system assigned identity is used by default, although the user assigned identity can be specified with credential and client ID properties. When run in other contexts, such as a local development, your developer identity is used instead. Grant permission to the identity. Whatever identity is being used must have permissions to perform the intended actions, and that sounds logical to me, because if you're not allowed, why would you be able to do things? This is typically done by assigning a role in the Azure role-based RBAC, or specifically identity in access policy, depending on the service to which you're connecting. Some permissions might be exposed by the target service that are not necessary for all contexts. When possible, adhere to the principle of least privilege, granting the identity only required privileges. And that's a common practice, that you share as little as possible basically preferably nothing. That's also what you see when you're logging into your to some system, and if the system would say, well, your connection to database XYZ is failing, that gives you as a hint that you are actually accessing database XYZ. So don't say that. Just say that it's failing. Exercise. Create an Azure function by using Visual Studio Code. In this exercise, you learn how to create C# function that respond to HTTP requests, and after creating and testing the code locally in Visual Studio Code, you'll deploy to Azure. Before you begin, make sure you have the following requirements in place: an Azure account with an active subscription. If you don't already have one, you can sign up for a free trial. The Azure function core tools. I'm not sure if I have that available. I do have an Azure account. Oh. What are the Azure function core tools? Yeah, and the interesting thing is that I probably, if I install that, it will be throwing security dialog. Or maybe not. npm chocolate winget. We do have winget. Let's try that. Thank you for following Mandragorax. Mandragorax. Let's go to E here. I said E. I didn't see the notification again. Did it show your name in there? Data repos. Directory 2024 05 15. CD 2024 05 15. Doesn't use the folder here, but just make sure that we're not messing around with the wrong folders. Winget install. Let's see if that's doing it. Hoping it won't throw up an elevated prompt. In the meantime, let's have a look at the other requirements. Visual Studio Code, I do have Visual Studio Code, VisualStudio.NET higher than 6, that's available. C# extension, I think that's installed. Azure Functions extensions. I'm not sure if I have that installed. Let's wait for the thing to be finished. Remains at 0%. Oh, there's something coming there. I guess it was downloading it first. 99%. Is that the downloader or the installer? I think it's now installing. Application license to you by its owner. Microsoft not responsible. Microsoft never responsible. Downloading. Now it's downloading. Not sure what it did before that. Function CLI. Let's make this a little bit bigger so that you can see what's happening there. Oh, where is it? So that you can also see what's happening there. Did a lot of your peers lose their jobs in 2000 and 2008? We heard a lot of software engineers who lost their jobs around that time, never recovered, and just ended up choosing different profession. Oh, there's my... darn it. That was an elevated prompt, so now I think your screen is frozen. Yes, so I need to fix that. That's a nice thing for when you're installing things, because I'm not showing it's on the screen, but you don't see it. Let me try to fix that. General change. Local. Screen number 4. I hope. Okay. Let's see if we can bring the screen back. I think that did the trick. Yes, it's back again. Oh. Everything was minimized on all my screens now. That's not nice either. I have to reorg all my screens again. Let's see if this is still working. Yes. Your question, Paddy Wagon. A lot of people laid off in between 2000 and 2008. I think they did indeed, but there's never a time to give up, because as you can see now, there is a lot of demand for people developing software. So if you're probably already too late, because if you now start studying, then, well, at the time that you finish, then everyone is out of jobs through AI, maybe. I think the best thing would be to learn on the job. Just try to get someone hire you and allow them that you can learn the things on the job. Why is this taking so long? Is this so big, Azure Functions? Hopefully it doesn't drop my frame rate. I think so far everything's working fine. Thought maybe we could already have a look at the what we need to do here. We're going to create a project that immediately needs probably software already. Oh, it's successfully installed. Nice. So let's start with Studio Code then. VS Code. Oh, what? Code. Where is it showing up? On my other screen, again, restricted mode is intended for safe mode browsing. Now the question is, do I have an Azure thing available here? That's this one, Azure Function Extension. Azure Functions. The Azure pipelines failed, so that's interesting. Oh, it did not, it's just, yeah, the only one, the last part. So let's try and find the Azure Functions thing in here, the extensions. I also see that we have a lot of updates apparently. Azure Functions. It says it's installing. Did I ask for that to install it? Or do I need to click this? I don't know. What is this? Welcome to the new version of VS Icons. Yeah, it's interesting. Not at all. And it's now installed apparently. This extension has been disabled because your current workspace is not trusted. Why not? Open a folder. C, no, not CE. Data repos 2024 05 15. Select folder. Is it now secure? There's nothing in there yet. Is there more that we need to download there? Oh, there's a lot more installing. Keeps us busy. And we have a recommendation for Docker and for Gemini. Let's go through the documentation here. Choose an Azure icon. Choose the Azure icon in the activity bar, then the workspace area, and select Add. So this. We have a lot of bookmarks now. Let's close that and close the welcome there. Here we have workspace. I think we have a local workspace there. Choose Azure function when select add. Finally, create a button. I think that's already done automatically here. Let's follow this thing. Choose the Azure function that we have done. Then the workspace area, select add. And there's no add, there's one here, create resource. But that's not a workspace. So that changed already, apparently. That's also always the nice things with these learning things. Then we have create function. I think guess that's this one. Yeah, there we have create function. Pop-up will likely appear prompting you to create a new project. If it does, select create new project. If it does, select create new project. Create new project. Select the folder that will contain your function project. And that can be the current one. And the language. Choose a directory, that's what we did. Select language, choose C#. Then choose .NET 6. Wonder why it's choosing .NET 6. Let's take long-term support. I'm always tempted to pick the newest one like the .NET 8, but usually then the learning things are not working. Choose HTTP trigger and give that a name. HTTP example. Copy. Press enter. Provide a namespace. My function. My function. Hit enter. Authorization level, choose anonymous. It's creating a new project now. See, it's already different than what we see on Microsoft Learn. That's a little bit annoying. Choose add to workspace. Because this was not being asked. Where were we? Here. It's downloading, still downloading things. Sign in to use your subscription. I guess it's about this one. Installing packages like Razor length service telemetry. Using .NET config. I think that's already by default on the machine as well. So let's go back to the documentation here. Using the information VStudio code generates the functions project with an HTTP trigger. Run the function locally. VStudio code integrates with VStudio functions core tools to let you run the project on your local development computer before you publish to Azure. Make sure the terminal is open in VStudio code. You can open the terminal by selecting terminal and new terminal in the menu bar, but that's also just available here. The question is, which one will it open by default? PowerShell. Then new terminal. We're already in the terminal. Press F5 to start function. App project in the debugger. Output from core tools is displayed in the terminal panel. Thank you for following Frostern 1216 1216. Appreciate it. Let's see, F5. Let's F5 here and see what it will do. Nothing. Is it doing something? You must have Azure Functions Core Tools installed. But I did, didn't I? It's doing it again from npm. It's recommended you upgrade from 2.3 to 7. So what does it say here? Is it installing something? npm does not support Node 14.15. You should probably upgrade to a newer version. Okay. Interesting. So we need to go to Node. Google. Upgrade Node. Command line. Let's accept all the cookies there. Node.js.org. I think from my memory. Yes. Do we get another elevated prompt here? Open. Come on. Next. Accept. Next. Node.js. I guess everything is okay. Automatically install the necessary tools. Also include Chocolatey. No, don't want Chocolatey. And here we have another elevated prompt again. There we are. Now the question is, did that break my screen again? It did. Oh. So now I need to fix my screen again. And it says something is in use there. Hoping it won't break my stream here. Let's first fix my screen there, so that you can see what's happening here. Come on. My camera is still working. Yeah, come on. Today, maybe. And the screen is back, I think, now. Let's close this. And that will probably also install my Visual Studio Code again. Let's do a little bit of cleaning here. That's the live stream. That's the certification. That's what we're working on. This is what we're in now. This is how we install the tools. That's the command line, and that's the Node.js. Let's close the app. Let's see what's happening. If we drop off, then you know why things are failing. The joy of live streaming and installing. No. The setup was unable to close all the requested applications. Please assure. That means that we need to reboot there, probably. Before, yeah, okay. And I'm not going to reboot. If that's the case, then we are going to wait for the break. But even that, I don't want to stop the stream. Component registration. What we can do in the meantime is have a look at the next one. Because if you see all these things, I apparently did all these things before already, but you can start with the key vault, if that's just theory. Implement the Azure Key Vault. Learn how Azure Key Vault can help you, blah, blah, blah. And the goals are to describe the benefits to Azure Key Vault, how to authenticate using the Azure Key Vault, and set and retrieve a secret. That's not that difficult. Introduction. Azure Key Vault is a cloud storage for securing storage and accessing secrets. These days you can also, by the way, it's not in here. Oh, it's in here. Store certificates. Secret is anything that you want to tightly control access to, such as API keys, password certificates, and cryptographic keys. After completing the module, you'll be able to describe the benefits of using Azure Key Vault, explain how to authenticate to the Azure Key Vault. Let's make a new page here. And, Azure Key Vault. Is it done already? No, it's not. So I made a new notes page there on the other screen. Complete module. No, I want to go to next. The Azure Key Vault services support two types of containers: vaults and managed hardware security modules, ASM pools. I think that's new. Vaults and hardware security module, ASM pools. Vault supporting storing software HTML, HSM backed keys, secrets, and certificates. That's in the certificate things. Managed HSM pools only support HSM backed keys. Thank you for the following alpha up. So what we're doing here is we are working on the AZ204 certification renewal process. I think that's in here. The Certified Azure Developer Associate certification, and we are currently waiting for the install for the Azure functions. Not sure if that's going to happen today, but let's try at least. In the meantime, we proceed with the key vault. That was this one. Azure Key Vault helps us solve the following problems: secret management. Azure Key Vault can be used to securely store and tightly control access to tokens, passwords, certificates, API keys, and other secrets. Key management. Azure Key Vault can also be used as a key management solution. Azure Key Vault makes it easy to create and control the encryption keys used to encrypt your data. Certificate management. Azure Key Vault is also a service that lets you easily provision, manage, and deploy public and private secure socket layer SSL or TLS transport layer security certificates for the use of Azure and your internal connected resources. Azure Key Vault has two service tiers: standard, which encrypts with the software key, and premium tier, which includes the hardware security module protected keys. So I think if you want to use certificates, you always drop back to the premium one. It's not dropping back, moving up to the premium tier. See the Azure Vault pricing page. So we have the vaults, standard operations, same pricing. The pricing is all the same. Software protected keys, and in this case it's HSM protected keys is not available in the standard scenario. It is in the premium. $1 per key per month plus 3 cents for every 10,000 transactions. Key benefit of using Azure Key Vault: centralized application secrets. Centralizing storage of application secrets in the Azure Key Vault allows you to control their distribution. For example, instead of storing the connection string in the app's code, you can store it securely in the Key Vault. Your application can securely access information they need by using URIs. These URIs allow the application to retrieve specific versions of a secret. I think GitHub now also has that in place. Securely store secrets and keys. Access the keys for the Key Vault requires proper authentication and authorization before a caller, user, or application can get access. Authentication is done via Microsoft Entry ID. That used to be Azure Active Directory, I think. Authorization may be done via Azure Role-Based Access Control, Azure RBAC, or Key Vault Access Policies. Azure role-based access control can be used for both management of the vaults and to access data stored in the vault, while key vault access policy can only be used when attempting to access data stored in the vault. Azure Key Vaults may be either software protected or with the Azure Key Vault Premium tier, hardware protected by hardware security modules. Monitor access and use. You can monitor activity by enabling logging for your vaults. That might help if you want to know who is actually accessing your secrets there. You can monitor that. You have control over your logs and you may secure them by restricting access, and you may also delete logs. That's good news that you also may delete things you no longer need. Azure Key Vault can be configured to archive to a storage account, stream to an event hub, or send the logs to monitor logs. Let's make a note of that, because that might be a question. It could potentially be a question. Simplified administration of, where's my mouse? There's my mouse. Simplified administration of application secrets. Security information must be stored, must be secured. It must follow a life cycle and it must be highly available. Azure Key Vault simplifies the process and meeting these requirements, removing need for in-house knowledge of hardware security modules, scaling up to short notice to meet the organization usage spikes, replicating the contents of your key vault within a region and to secondary region. So you also have a backup there. Data replication ensures high availability and takes away the need of any action from the administrator to trigger a failover. Providing standard Azure administration options via the portal, Azure CLI and PowerShell. Automation certain tasks on the certificates that you purchase from the public CAs such as enrollment and renewal. Discover Azure Key Vault practices. Let's quick have a look here. Still busy. Azure Key Vault is a tool for securely storing and accessing secrets. Secrets, anything that you want to tightly control. Control access to, such as API keys, passwords, certificates, and the vault is logical group of secrets. Authentication. We have a dog barking outside. Not sure if you can hear that in the stream. I can hear it. To do any operation with Key Vault, you first need to authenticate it to it. There are 3 ways to authenticate to Key Vault. Manage identities for Azure resources. When you deploy an app on virtual machine Azure, you can assign an identity to your virtual machine that has access to the Key Vault. You can also assign identities to the other Azure resources. The benefit of this approach is that the app or service isn't managing the rotation of the first secret. Azure automatically rotates this service principal client secret associated with the identity. We recommend this approach as the best practice. That's basically also what I use, I think, for the website. Completed NSJS Node.js. Click the finish button to exit the setup. Node.js has been successfully installed. Hoping it won't be a rebooting. No. So let's proceed with where we were. Other screen. Let's blow this up again. eData repos. No, cd data repos, cd 2024-05-15. Code dot. Let's see if it opens the same thing again. Looks like it. Terminal. Downloading Razor telemetry package. When did I ask for that? In the meantime, let's see how we can find the latest version here. Check version Node.js. I think it's just dash version or something, yeah. It's updating all these things here. You usually do things in like virtual machines, but I wanted to try this first on the local machine. Maybe not the best decision there. Node. Oh. Node version. Super slow. Twenty 13.1. Interesting that the time is completely misaligned here. Let's see if we can run F5 again. Activating extensions. Something is happening here. Oh, we also have Copilot in place. Build started. Terminal will be reused by tasks. Press the key to close it. Let's try find the dialog that matches with this. That's the one that we already checked. This is the extension. I think this one. We had to run F5. We created a local project here. Run locally. Make sure the terminal window is open. That's what we did. Press F5 to start function app project in the debugger. Output from core tools is displayed in the terminal panel. Your application starts in the terminal panel. You can see the URL endpoint of your HTTP your HTTP triggered function locally. Failed to detect the running functions host within 60 seconds. No, but it's still running. Found project using for user secret configurations. There it is. Host lock, please acquired. So let's question. This is what we see here. With the core tools running, go to the Azure Functions area. Under Functions, expand local project functions. Right-click the HTTP example and choose Execute Function Now. Workspace, functions, workspace. Do we have a workspace? Oh, we need to select this one. The Azure Functions add-in. I think it's reading now. And it says local project functions, local functions. There we are. HTTP sample. We need to right click that and execute function now. In the request body, type execute function now. In enter request body type the request message of value name Azure. Press enter to send this request to your function. Enter. Send to when the function executes locally and returns the response, notification is raised in Visual Studio Code. Information about the function execution command is shown. Information about the function execution is shown in the terminal panel. Where was the run? Executed HTTP sample example succeeded with something and a duration. Press Shift F5 to stop the core tools and disconnect from the debugger. After you've verified that the function runs correctly on your local computer, it's time to use Visual Studio Code to publish the project direct to Azure. See that? Then, if you aren't already signed in, choose the Azure icon. That's what we already did. And in the Azure Functions area, choose Sign into Azure. The resources here. Allow. Let's bring in the secret screen quickly. Everyone, do you have an opinion about ThinkPads? Please share with me. I'm thinking about buying a X2020 2020 for $80. That's no money at all. I think I have an ThinkPad, but I think it's an X1. It's showing me. Let me show my screen quickly. It's showing this thing. Your Azure function core tools, if it's allowed, is to run on public access. And now we're going to in an elevated thing again. Story of my life. I said allow access. Nothing happens. Other than that, my screen is locking up now. Let's quickly go to secrets here. Just waiting for Azure to assign in, but it's not showing anything there, maybe. You're signed in and you can now close. So close this. And we can now probably go back to the screen again, if that's still working. Please select an account. There we go again. Secrets again. Sign in using a Microsoft account. I think we already did that. And back to the screen. Not sure what's happening there. We first need to finish this. Shift F5 to stop core tools. Shift F5? Shift F5, yeah. Shift F5. Does it now stop something? I don't think so. Nothing is happening. Start. Okay, let's have a look here. We sign in. Cosmos and Azure MSDN. I think that's one. Why do I have two? Like a PyScope thing. Interesting. My screen is still on here. Let's see. Go back to the screen. Where were we? Here. Sign into Azure. That's what we did. If we aren't already signed in, choose the icon. That's what we did. When prompted in the browser, choose your Azure account. That's what we did. After you successfully sign in, you can close the new browser window. Subscription that belong to your Azure accounts are now displayed in the sidebar. Yeah. create resources in Azure. In this section, to create Azure resources, you need to deploy to your local function app. No, you need to deploy your local function app into resources. Choose the Azure icon in the activity bar, then in the resources area, select create resource. And let's read it first. Provide the following information at the prompt. Select create function. Where is this? Resources. Plus. And what we are going to do is create function app in Azure. Create function app in Azure, this one. And it will create it in the MSDN. Unique name. Enter globally unique name for the function app. Type the name that is valid in a URL path. Name you type is validated to make sure that it's unique in Azure Functions. So that's what's the thing again? AZ204, AZ204 2024-05, and today is 15. And let's extend that with 1. Let's copy that to the notes here. Make that bold so that I remember what it is. And then hit enter. And it's going to be select runtime stack. Use the same choice as you made to create a local project. So that's the 6 long-term support. Some stacks have an end of support deadline. Yeah, anyway, I selected the .NET 6 long-time support. Its use and runtime has an end of support. Yeah, I know. Then you should update your learning things. However, your apps won't be eligible for new features, security patches, and more. I want to continue. And select the region. The location, that's like West Europe in my case. Something is happening here. Select subscription, that was already done, I believe. You won't see this if you only have one subscription. But I think you started with that, didn't you? You started with that here. No, not really. But it was a question that we got in the meantime. No other dialogues on the screen, I think. Let's have a look at the output. Oh, there it is. Successfully created function. View output. Nice, that's this. Now everyone is going to bash that. not sure that has access to anyone. Go back to here. The extension shows the status of the individual resources as they've been created in Azure. In the Azure activity log area of the terminal window, that was basically this thing. When completed, the following Azure resource created in your subscription using named using names based on the function app name, a resource group, which is a logical container, a standard storage account, oh, we can have a look at that quickly, maybe. Let's move to this here quickly. For that, we need to open the portal just to make sure that I'm not hiding, showing a lot of this information. Toggle masks are on, resource groups. And the question is, I think it's this one. 2024 I think it's this one. Yes, let's share that in screen. So indeed, what we see here is that it created a storage account, an app insights, and a function app, and an app service plan. Resource group, local container for the resources, creates a storage account. Not that one. This one. Storage account is this one. Consumption plan. I guess that's this one. Service plan. And a function app. So that's the other one. That's this one. An application insights instance. That's the one with the light bulb in there. So it's all there. Deploy the code. In the workspace section of the Azure bar, select the deploy button. And then select deploy to function app. That we need to go in here. And is there the arrow is upside down. Let's download. In the workspace section of the Azure bar, select the deploy button and select deploy to function app. But there is no. We do have function app here. Question is, did it do it automatically already? Deploy to function app. So it's completely different because it's I think they changed it. I do this, deploy to function app. Are you sure you want to deploy to any previous deployment? Yes, deployment. But what are we deploying here then? How does it know what to deploy there? So what I think is that this one is now moved over to a different location. Because that was not on that location. They really need to update their learning environments, don't you think? Hit the like button if you agree with me. Because this is really annoying, so probably will bring that to the Azure environment as well. Still publishing. Something's happening here. Deploy to app. Azure something. Luckily I don't have other functions, so I can't mess this up. Hopefully. What does it say? Deployment completed. Stream logs, upload settings, view output. Let's have a look at the output. So now we have this HTTP example there. So we should be able to go in here according to the, there you are, HTTP example. HTTP example, so we now do execute function now. Right click, execute function now. We have the same thing as your name. There we are, hello. I think it actually worked. Where's the output? Debug? No. I wonder where the output went. Terminal? No. Let's try this again. execute function HTTP sample response hello Azure. This HTTP trigger function executed successfully. I think that's an applause. Great. Now the question is, how do we tear this down? By just deleting the resource group. Let's make a note of that. I need to remove the resource group there. Nice. So we created our first thing. Let's have a look at this quickly because it's where is it? Where's the code for that thing? Oh. Building again. Where's the code for this thing? In here. So what happened here is that it's sending, you're running the HTTP sample and then doing some logging there. And then in the end, it will show you that it was successfully run. There's a name as a parameter. Cool. I think that's fully functional. Let's do the knowledge check there. So bring in your votes again. Check your knowledge. Which of the following choices is required for Azure functions to run? Is that a binding? Is that a trigger? Or both triggers and bindings? Let me hear it in the chat. Everyone, come on. Second question, which of the following choices support both the in and out directions? Is it bindings, triggers, or connection value? So my guess would be required to run is the trigger. Although there might be something to be said about triggers and bindings, but I guess triggers. And following the choices, I would say the bindings in and out, like so. And it looks like that's good. Review the answers. Correct. Trigger defines how a function is invoked, and the function must have been exactly one trigger. Then we have the bindings using in and out. So that's excellent. What are we? 5:45. We started at 3, 4, 5. We're almost 3 hours in now. Continue. And we complete the module. That's good. So we now did the functions completely. That's the key vault. So we should now have completed this as well. Thank you for the follow. Cheaton 1001 1001. Guess that's not your date of birth. Why is it not showing anything here? Oh, it is. So we now have the Azure functions also as well. Let's continue with the key vault. We already started a little bit here. In here. No, it's not. What's not? One oh one 1001. Oh, it's not my birthday. Yeah. Oh, I already forgot about my remark when I actually made it. Maybe it's 2001 could be an option. Then you would be like 23 already. I'm really from the last century, so I won't get into that too much. Authentication. To do any operation with Key Vault, you first need to authenticate to it. There's 3 ways to authenticate. Manage identities. That's basically Azure Active Directory things. Service principal and certificate. You can use the service principal and associated certificate that has access to Key Vault. We don't recommend this approach because the application owner and developer must rotate the certification. I think you could do that automatically these days, but not sure. Service principal and secret. Although you can use the service principal and secret to authenticate to the key vault, we don't recommend it. So actually the only recommendation is managed identities for Azure resources. Managed identities for Azure. I think that's Entra these days. Encryption of data in transit. Azure Key Vault enforces transition layer security protocol to protect data when it's traveling between Azure Key and Key Vault. No, between Azure Key Vault and clients. Client negotiation TLS. Connection with Azure Key Vault TLS provides a strong authentication, message privacy, and integrity, enabling detection of message tampering, interception, and forgery, interoperability, algorithm flexibility, and ease of deployment and use. Quickly check my phone here. Someone needs something from me. Where were we? The TLS thing. Perfect forward secrecy protects connections between customers' client systems and the Microsoft Cloud services by unique keys. Connections also use RSA-based 2048-bit encryption key length. This combination makes it difficult for someone to intercept and access data that is in transit. Azure Key Vault best practices use separate key vaults recommended using a vault per application per environment. Development, production, pre-production, and production. We call that development, staging, and production usually. This pattern helps you not share secrets across environments and also reduces threat of if there's a breach, not a branch, breach. And I also think that development levels in pre-production is completely different to production. You never share these things among these ranges. Almost running out of water already. Control access to your vault. Key vault data is sensitive and business critical. You need to secure access to your key vault by allowing only authorized applications and users. Well, that's a surprise. You don't share your passwords with strangers, do you? Backup. Create regular backups of your vault. On update, delete, create of objects within a vault. Always do your backup, you know. Logging. Make sure that you know who is accessing your system. Recovery options. Turn on soft delete and purge protection if you want to guard against forced deletion of your secrets. Oh, that was not what I wanted. I wanted to, because I already did that, it's moving immediately to the next, to the end of the session. There's soft delete, so we now have to use this one. Authenticate to Azure Key Vault. Authentication with Key Vault works with Microsoft Entra, or what we used to call Azure Active Directory previously, I think, which is responsible for authenticating the identity of any given security principal. For applications, there are two ways to obtain a service principal. Enable the system assign managed identity for the application. With managed identity, Azure internally manages the application service principal and automatically authenticates the application with other Azure services. Managed identity is available for applications deployed to various services. If you can't use managed identity, you instead register the application via your Microsoft Entra tenant. Registration also creates a second application object that identifies the app across all the tenants. It's recommended to use the system assigned managed identity. The following is information on the authentication of the key vault without using managed identity. Authentication to key vault in application code. The key vault SDK is using Azure Identity Client Library, which allows seamless authentication to key vault across environments with the same code. The table below provides information on the Azure Identity Client Libraries. In .NET is Azure Identity SDK.NET, Python, Azure Identity SDK Python, Azure Identity SDK Java, and Azure Identity SDK JavaScript. You could predict it yourself. Authentication through to key vault with REST. Access tokens must be sent to the service using HTTP authorization header, where you put the API version in authorization bearer token. When an access token isn't supplied or when a token isn't accepted by the service, and HTTP 404 error is returned to the client and will include a authenticate header, for example. 404 not authorized, authentication, bearer authentication, no, bearer authorization. Authorization and identity authentication are two different things. Authentication is who you are, and authorization is are you allowed to access it, and the resource is what are you accessing. The parameters on www authenticate header are authorization, the address of the authorization service that may be used to obtain or access a token of the request, resource, the name of the resource, vault, Azure.net, and vault is the name of the vault, actually. Not complete, I want to go to the next one. Exercise: set and retrieve a secret from Azure Key Vault by using Azure CLI. In the exercise, you learn how to perform the following actions by using the Azure CLI. Create a key vault, add or retrieve a secret. Prerequisites: the Azure account has an active subscription. If you don't already have one, you can sign up. I do have one available. Sign into the Azure portal. I do have the portal open already. Go to the portal. Let's quickly go to the thing there. To the portal, and I'm opening the. Oh, I can share that probably. Otherwise, too bad. Connecting to terminal. Now the question is, do we get a bash? Doesn't say switch to bash. Is this PowerShell? This PowerShell, switch to bash. Confirm. The exercise was in bash, I believe. This one. Let's set some variables for the CLI commands to reduce the amount of typing. Replace my location variable with the region. Now the question is, what's the name of the region? I have to look that up again. West Europe. Copy. Paste. No, that's not what we need here. Editor. Let's show bash. My key vault. Copy. I don't think it's allowing me to paste anything in here. My key vault. Go back here. My guess is that location needs to be West Europe without a space. AZ location West Europe. Command line. I know we're in Europe. List locations. Region. It's not on the list, but it's without a space. Europe. Europe West. Apparently. Europe West. Europe, where's Europe? West Europe. There it is. And the thing was this one, so we can close this. My location is West Europe. My location is West Europe. Then we do something like this. Copy. Azure group, it creates a group, resource group, create with the name Azure204 Vault resource group. The location is my location. That was now created, I think. Quickly switch to that resource group. Refresh. Yeah. Back to screen. You maybe. Go back to here. No, here. Create a key vault by using the Azure key vault create. That will use the name of the resource group. No, that's not what we wanted. Let's go here again. Copy. That's better. Azure key vault create, name my key vault group. The resource group that we just created there. enter. We will enable role-based authentication by default in the near future. Please manually specify enable role-based access control authorization if you want to override the default value. Can we blow this up a little bit? Oh, we can. Okay. So if we now refresh the resource group, now we have a key vault. Takes a few minutes. Add and retrieve a key secret. Create a secret. Add a password that can be used by an app. Password called example password. Copy. Plain text. Azure Key Vault secret, set vault name, my key vault, example password, and some password in there. Now we have some information there. Then use the key vault secret show command to retrieve the secret. Copy. Now let's click the button there. Otherwise we get all kinds of rubbish here. Plain text. Azure Key Vault secret show something. And then this command returns this on JSON. The last line contains the password in the plain text. There we are. And this one cleans up the resources as well. So that's good. Group, Azure, Vault, copy, plain text. And you want to do this? Yes, we want to do this. So if I now try to get the secret again, it will fail. It should fail at least. Right. Clear. Nice. So that works. So if we recap, what we did was we had a key vault name in the location West Europe. We created a group, resource group, named AZ204 vault region in my region. Then we created the key vault with the name that we provided earlier here. And we put a secret in there. It's raining and thundering outside now. Can you hear that in the stream? I don't think so, but what page are we on? 5 of 7 next. Check your knowledge. Which of the below methods of authentication to Azure Key Vault is recommended for most scenarios? Oh, hit the chat again. Throw in your answers. Is that service principal and certificate? Or is that service principal and secret? Or is that managed identities? The second question, Azure Key Vault protects data when it's traveling between Azure Key Vault and clients. What protocol is used for the encryption there? Is that secure socket layers? Or is that transport layer security? Or is that the pre-center layer? 10 seconds. Managed identities and TLS. Guess what sheet on 1001. Are you the only one with this answer? Two seconds. There it is. My answer would also be managed identities and TLS. It's not presentation layer, and secure socket layer is, I think, for the certificates. Let's check this. And it's both correct, managed identities, because the other ones were apparently, and I made some notes of that, not recommended at all. Source principal and certificates was not recommended. The source principal and secret was also not recommended. The benefit of this approach is that Azure automatically rotates the identity. That's something different than what was just mentioned in the text, I think. There was still that mentioned. That's not. But then maybe that's the certificate. Might be wrong. The Azure Key Vault enforces transport layer security protocol to protect data when it's traveling between Azure Vault and Key Vault. Complete module. Keep up the great work. I think we did now 3 modules. I don't get extra additional points on that because I already did this one in my previous years, I guess. All check marks are in place. Good. Now let's have a look at this. We did the Azure Functions and the Azure Key Vault. Now we have the app configuration. How many do we have to go? In total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to run out of time, I guess. Because we're now 3 hours and 15 minutes in. We finished 3. That's almost an hour for each one. Maybe there are some short ones in 21 minutes. That's a good one to do before going into dinner, I guess. Although my water is, I'm running out of water. That's a sad thing. But I can keep that up a little bit. This is also done by me in my previous renewals, so it's apparently not changed, but it's good to refresh the memory here. Objective goals. Explain the benefits of the user, the Azure app configuration. Azure app configuration stores information, implement feature management. This is interesting because I forgot about that a little bit already. Securely access your app configuration information. So let's proceed here. Introduction will probably show the exact same thing. Right, so we can skip that. Explore the Azure App Configuration Service. The Azure App Configuration provides the service to centrally manage application settings and the feature flags. Modern programs, especially programs running in the cloud. I need to make a new page here as well, because we're wrapping up the Key Vault now. This will be Azure App Configuration. Azure App Configuration provides a service to centrally manage application settings and feature flags. Modern applications, especially programs running in the cloud, generally have many components that are distributed in Azure. Spreading configuration settings across these components can lead to hard to troubleshoot errors during an application deployment. Use application configuration to store all the settings for your application and secure their access in one place. App configuration offers the following benefits: fully managed service that can be set up in minutes, 21 minutes to be exact. key representation mapping, tagging with labels, point-in-time replay of settings, dedicated UI for feature flag management, comparison of two sets of configurations or custom-defined dimensions, enhanced security through Azure managed identities, encryption and sensitive information at rest and in transit, native integration with popular frameworks. .NET, for instance, allows 3 levels of user secrets, I think. Maybe 4 even. User level, application level, Azure level, and then the key vault. App configuration complements Azure key vault that we just used, which is used to store application secrets. App configuration makes it easier to implement the following scenarios: centralized management and distribution of hierarchical terrible. If you come from the Netherlands, that's a difficult word. Configuration data for different environments and geographies. Dynamic change application settings without the need to redeploy or restart an application. Control feature available in real time. Use app configuration. The easiest way to add an app configuration store to your application is through a client library that Microsoft provides based on the programming language and the framework. The following best methods are available to you. .NET Core, that's what we're using. App configuration provider for .NET Core. .NET Framework, that's the old one, I think. Fat client. App configuration builder. That's basically in the middleware for the other one as well. Java Springs, app configuration client. App configuration client for JavaScript. Python is, these are all clients, Java, JavaScript and Python. Then all others have app configuration REST APIs. Basically everyone can handle REST APIs. Next, page 3, create paired keys and values. Azure app configuration stores configuration data as key value pairs. The keys serve as the name for the key value pairs and are used to store and retrieve corresponding values. It's common practice to organize the keys into hierarchies in Dutch. Come on. Copy. Pronunciation. Does it say it?
Hierarchical.
Hierarchical. That's a terrible name for Dutch people. Hierarchical. That's terrible. Hierarchical. That's a hierarchical namespace by using character delimiters such as / or semicolon. Use a convention that best used for your application. I think in general for .NET it's hierarchical namespaces are used with a semicolon. App configuration treats keys as a whole. It doesn't parse keys to figure out the names, how their names are structured or enforce any rule on them. quickly need to check. My wife's already preparing dinner or something. I don't know. I don't think so. App configuration trees as a whole, blah blah blah. The keys stored in app configuration are case sensitive, Unicode based strings. The keys app1 and app1 with capital A are distinct in app configuration store. Keep in mind that when you use configuration settings with an application, because some framework handle configuration keys case insensitive. You can use any Unicode character in key names entered into the app configuration except for star, comma, and backslash. These characters are reserved. If you need to include the reserved characters, you need to escape it by using backslash and then the escape character. There's a combined size limit of 10,000 characters. Why would you ever use a 10,000 character key value pair? This limit includes all characters in a key. All characters in a key. So if you have a lot of keys, then you might hit the 10,000 keys there. That's potentially a risk. Then you probably need to split them up a little bit. The limit included in all characters in a key, its value, associated optional attributes. Within this limit, you can have many hierarchical levels. I'm learning here. Hierarchical levels for keys. Design key names, namespaces. There are two general approaches to naming keys used configuration data: flat or hierarchical. These methods are similar. I guess at the end of the show, I actually know how to pronounce hierarchical. So the one thing that I learned today is how to pronounce hierarchical. These methods are similar from an application user standpoint, but hierarchical naming offers many advantages. Easier to read instead of one long sequence of characters. The limiters in a hierarchical key name function as spaces in a sentence. Yeah, so you basically create this tree separated by semicolons in there. Easier to manage. A key name hierarchy represents logical groups of configuration data. Easier to use. It's simpler to write a query that pattern matches keys in a hierarchical structure and retrieves only a portion of configuration data. Following some examples of how you can structure your key names into a hierarchy based on component services as app name, service name, API endpoint, all split with semicolons, or by regions, app name, region, and the DB endpoint, for instance. Label keys. Key values in app configuration can optionally have a label attribute. Labels are used to differentiate key values with the C. A key app with labels A and B forms two separate keys in app configuration store. By default, the label for a key is empty. The label for a key value is empty or null. A label provides a convenient way to create variants of a key. A common use of the labels is to specify multiple environments for the same key. That it means like key is application, app name, DB endpoint, and label is test, staging, and production. So in this case, it's adding label. Label keys, yeah. Key values in app configuration can optionally have a label attribute. Yeah. Version key values. App configuration doesn't version key values automatically as they are modified. Use labels as a way to create multiple versions of a key value. For example, you can input an application version number or a git commit ID in the label to identify key values associated with the particular software build. Query values. Each key value is uniquely identified by its key plus label that can be null. Your query an app configuration store for key values by specifying the pattern. The app configuration store returns all keys values that matching the pattern and their corresponding values and attributes. Values assigned to keys are also Unicode strings. You can use all Unicode characters for values. There's an optional user-defined content type associated with each value. Use the attribute to store information, for example, an encoding scheme about the value that helps your application to process it properly. Configuration data stored in an app configuration store, which includes all keys and values, is encrypted at rest and in transit. App configuration isn't a replacement solution for Azure Key Vault. They don't store application secrets in it. Can be, but doesn't need to be. Page 4. Manage application features. Feature management is a modern software development practice that decouples feature releases from code deployment and enables quick changes to the feature and the availability on demand. It uses a technique called feature flags, also known as feature toggles, feature switches, and so on, to dynamically administer a feature life cycle. Basically, what it means is that you put a flag in there, and if according to the availability of the flag, a feature is shown or not. That's what I think that's meant here. Basic concepts, just let's read about it and see if that's true, if I remember it correctly. Basic concepts. Here are several new terms related to feature management. Feature flag. A feature flag is a variable with a binary state of on or off. The feature flag has also has an associated code block. The state of the feature flag triggers whether the code block runs or not. Feature manager. Feature manager is an application package that handles the lifecycle of all the feature flags in an application. The feature manager typically provides extra functionality such as caching feature flags and updating the states. I'm hoping that I still have a voice tomorrow, because 8 hours of straight talking or reading things, that will hit my voice probably. My wife now messaging me if I wanted to eat at 7. That's about in half an hour. Feature flagging code. Oh no, we missed it a little bit here. An effective implementation of feature management consists of 2 components. An application that makes use of feature flags, a separate repository that stores feature flags, and current state. That's what we already were reading just now. How these components interact is illustrated with the following example. Feature flag usage in code. If feature flag something, then you will do something or not. In this case, the feature flag is set to true. The enclosed code block will be executed. You can set the value of the feature flag statically, as in the following code example. You can also evaluate the flag state based on certain rules, like its beta user in this case. A slightly more complicated feature flag pattern includes an else statement. If the feature flag, then you do this, and if the feature flag is not, so if you have, for instance, have a new or old feature, you can pick either one, depending on the feature flag put in the code there. Feature flag declaration. Each feature flag has two parts, a name and a list of one more filters that can be used to evaluate the feature status on. That is when the value is true. A feature filter defines the use case for when a feature should be turned on. When the feature flag has multiple filters, the filter list is traversed in order until one of the filters determines the feature it should be enabled. At that point, the feature flag is on and the remaining filter is scripted. If the no filter indication the feature should be enabled, the feature flag is off. So if it doesn't find it anywhere here, it will put off. The feature manager supports app settings JSON as a configuration source for feature flags. The following example shows how to set up feature flags in the JSON file. So in the app settings you can put something in there like feature management, feature A is true, feature B is false, feature C is enabled for 50%. That's interesting, so you can do like A/B testing, I guess. Feature flag repository. To use the feature flags effectively, you need to externalize all the feature flags used in an application. The approach allows you to change the feature flag states without modifying and redeploying the application itself. Exactly, because you want to keep that outside. So if you want to enable feature B, for instance, you set this value to true, and your application will detect the next time it asks for it that it's true. Azure app configuration is designed to be centralized repository for feature flags. You can use it to define different kinds of feature flags and manipulate the states quickly and confidently. You can then use the app configuration libraries for various programming language frameworks to easily access these feature flags from your application. Next, secure app configuration data. I'm running out of water here. Secure app configuration data. In this unit, you will learn how to secure your app configuration data by using customer managed keys, private endpoints, and managed identities. Encrypt configuration data by using customer managed keys. Azure app configuration encrypts sensitive information at rest using a 256-bit AES encryption key provided by Microsoft. Every app configuration, starting to stumble my voice here, instance has its own encryption key managed by the service and used by the encrypt sensitive information. Sensitive information includes the values found in key value pairs when the customer managed key available is enabled. App configuration used the managed identity assigned to the app configuration instance to authenticate with Microsoft Entra ID. The managed identity then calls Azure Key Vault and wraps the app configuration instance encryption key. The wrapped encryption key is then stored, and unwrapped encryption keys is cached within app configuration for 1 hour. app configuration refreshes the unwrapped version of the app configuration instance encryption key hourly. This ensures availability under normal operating conditions. Enable customer managed key capability. The following components are required to successfully enable the customer managed key capability for Azure app configuration, standard tier Azure app configuration instance, Azure Key Vault with soft delete and purge protection feature enabled, RSA HSM, that's the hardware key with Key Vault. The key must not be expired, must be enabled, and must have both wrap and unwrap capabilities enabled. Once the resources are configured, two types remain to allow Azure App Configuration to use the Key Vault key. Assign a managed identity to the Azure App Configuration instance. Grant the identity, get, wrap, unwrap permissions in the target Key Vault access policy. Use private endpoint for Azure App Configuration. You can use private endpoints for Azure App Configuration to allow, this is dry stuff to go over, to allow clients to virtual network, VNet, to securely access data over the private link. The private endpoint uses the IP address from the VNet address space for the app configuration store. Network traffic between the client on the VNet and the application configuration store traverses over the VNet using the private link on Microsoft Backbone network, eliminating exposure to the public internet. Using private endpoints for your app configuration store enables you to secure your application configuration and hit the subscribe and link button if you haven't already done so. Not lose track if this stream goes offline for some reason. Secure your application configuration details by configuration with a firewall to block all connections to the app configuration in the public endpoint. Increase security for a virtual network, ensuring the data doesn't escape from the VNet. Securely connect to the app configuration store from on-premise network that connect to the VNet using VPN Express or Express route with private peering. Managed identities. Managed identities from Microsoft Entra allows Azure App Configuration to easily access other Microsoft Entra ID protected resources such as Azure Key Vault. The identity is managed by the Azure platform. It doesn't require you to provision or rotate any secrets. Your application can be granted two types of entities: a system assigned identity that is tied to your configuration store. It's deleted if the configuration store is deleted. A configuration store can only have one system assigned identity. The user assigned identity is a standalone Azure resource that can be assigned to your configuration store. The configuration store can have multiple user assigned identities. Add a system assigned identity to set up a managed identity using the CLI. Use as AZ app config identity assign command against an existing configuration store. The following Azure CLI example creates a system assigned identity for the Azure app configuration store, my test app configuration store. That's AZ app config identity. Assign the name my test app config store in the resource group, my resource group. So it needs two things there. Is the name of the store and the resource group name. Let's copy that and put that in my notes there, because that probably will be a question. Add a user assigned identity. Creating an app configuration store with the user assigned identity requires you to create an identity and then assigns this resource identifier to the store. The following AZ example create a user assigned identity called my user assigned identity and assign it to the Azure app configuration store named my test app config store. It was this one. Create identity with the as AZ identity create command. AZ identity create. Resource group and the user assigned identity. Following examples, Azure CLI creates a user assigned identity called my user assigned identity and assigns this to the Azure app configuration store named my test app configuration store. This one. Assign a new user assigned identity to my test app configuration store. That's Azure app config identity assign name. My test config store, that's the same as the other one. Resource group, that's what we had as now as well. And from there you add identities. So that's addition on the previous command. Next. I said next. There we have a knowledge check again. There's the votes from the chat room. Which type of encryption does Azure app configuration use to encrypt data at rest? Is that 64-bit AES? Is that 128-bit AES? Or is it 256, 256-bit AES? Question number 2. Which of the following options evaluates the state of a feature flag? The state of a feature flag. Is that feature flag? Is that feature manager? Or is that filter? You have 30 seconds. Put in your votes. Ooh, we're running out of water. There we are, 8 seconds to go. My votes are 256. The state of the feature flag. I would say feature flag. Oh, that's not correct. I was already in doubt. Because let's go back in here. That's the identity. There. The state of the feature flag. Oh. Feature flag is variable with the binary state of on or off. The feature flag also is the associated code. Feature manager. So it has a feature, it has the state of on and off, but the filter is a rule for evaluating the state of the feature flag. A user group defines a browser type, geographic location, a time window. All examples of what a filter can represent. So if I search for filter here, there's not much of an explanation there. But apparently the filter is determining the state. Okay, next. Next. 256, and the other one should be filter. Check your answers. So the answer 256, the Azure app configuration encrypts sensitive information at rest at 256 AES encryption key. And the options evaluates the state of a feature flag is a filter. There's rules for evaluating the state of filter flag, feature flag. A user group, a device or browser type, a geographic location, and a time window can all be part of what represents the filter. Complete module. Great. I think we now have like 4 hierarchical. I think we did 4 modules in there right now. Let's refresh this because it won't change the status. I think because I already had done this module. So we did Azure functions, developed functions. We did it hands-on. We implement the Azure Key Vault. We now did the app configuration. So the next one would be monitor app performance. We have the container apps, container registry, container instances, and Cosmos DB. Not sure if we are able to make it all to the end. This one will be the next one. "24 minutes. Let's go quick through the intro. Monitor app performance. So we have 12 minutes before the break. Monitor app performance. Learn how to use the tools and app insights to enhance the performance and stability of your applications. Learn objectives are explain how Azure Monitor operates at the center of the monitoring Azure. Determine how application insights works and how it collects events and metrics. Instrument an app for monitoring, perform availability tests, and use application map to help monitor. And the things here are explore app insights, discover log metrics, instrument an app, select the availability test, troubleshoot, and knowledge. So let's go into start here. So start, edit, same thing repeated. Describe application insights works and collect the metrics. Go to page 2. Let's see how far we get. Explore application insights. Application insights is an extension of Azure Monitor. It's an extension of Azure Monitor, so basically it's on top up here, apparently. Add my page there. What's the module here? Monitor app performance. Monitor app performance. Based there, Application Insights is an extension of Azure Monitor and provides application performance monitoring, also known as APM. Azure Application Performance Monitoring. I did run into the APM acronym a lot. It's just like the military where you have all these acronyms and no one knows what it means. Expecting you to know what it means because it's part of your job. APM tools are useful to monitor applications from development through tests and into production for the following ways: proactively understand the application is performing, reactively review application execution data to determine the cause of the incident. So basically for bug triaging, things like that. In addition to collecting metrics and application telemetry, which is describe application activities and health, also can use it to determine if a feature is used or not. Application insights can also be used to collect and store application trace logging data. The log traces associated with other telemetry to give a detailed view of the activity. Adding trace logging to existing apps only requires providing a destination for the logs. The logging framework rarely needs to be changed. Application Insight feature overview. Features include but not limited to. So these are a few things: live metrics, availability, GitHub and DevOps integration, usage, how much is used from your application, smart detection, automatic failure and anomaly detection through proactive telemetry analysis. Application map, high-level top-down view of the application hierarchy. No, the application architecture, not hierarchy. At a glance, visual reference to the component, health and responsiveness. Distributed tracing. Search and visualize the end-to-end flow of execution transaction. What Application Insight monitors? Application Insight collects metrics and application telemetry data which describe the application activities and health, as well as trace logging data. Request rates, response times and failure rates. Find out. Good evening, Armageddon. No, not Armageddon. Armageddon. Armageddon 101. How are you doing? My apologies for asking, but I've been in software development scene for about 20 years and curious as your thoughts on AI and our careers as software engineers. I apologize and I assume you get this question quite a bit. Thank you for following Armageddon 101. Armageddon 101. That rhymes, so it must be true. AI, I think at this time it will help assist the developer a lot by asking the AI agent to explain your code maybe, or to write some boilerplate templates or things like that. At this time I don't think it's already building a complete app from scratch. There are applications, however, that can be generated by AI, like Flappy Bird. There's this AI that's basically capable of creating a Flappy Bird application, but that's not actually not, in my opinion, it's not generating it. It's just reading from the history, and there are a million examples of how to do Flappy Bird. So it would be strange if the AI instance is not able to build the exact thing based on the previous history. But at this time, I think it's like side wheels to your bike, helping you in your job. Things will change drastically, however, over the upcoming years. and you have to grow in it, and maybe you should be the one controlling the AI instance. You say not now, but should I pivot as a software engineer, as we would be extinct in 5 years? I think in 5 years will be a lot of things being extinct. For instance, what do you think about lawyers or accountants, or basically every job that's processing data or information potentially can be automated through AI? But yeah, I think it won't be done in 5 years already. And I think you already see it in like universities, that people, or that education is already changing. It's more like adapting to creating agents and AI things. So you definitely should pivot, but that's with everything. If you got your driver's license, you most like, at least in Europe, you had to get your driver's license and then you stick shift. These days, most cars are full automatic and have even like driver's assistance, and that's now adopted in the driver's license as well. How to handle those things in your car. So everything's changed, and that's the reason why I do this, because you need to learn every day. Every day you're learning new things, including the things that we are processing here. Where were we? Exceptions, application insights, exceptions, page views, Ajax calls, user and session counts, performance counters. Basically everything you can want to know about your application, if it's still running properly. Getting started with application insights. Application insights is one of many services hosted in Microsoft Azure, and telemetry is sent there for analysis and presentation. Armadon, I keep saying again, but Armadon, thank you so much. Thanks for the follow. Wilder Hives. I was saying Armadon 101 was saying thank you so much. You're super inspirational. Learning online in the open like this. You sound Dutch or Belgium. I'm Dutch actually. That's giving me this terrible accent. And that for that reason, difficult words like hierarchy. That's breaking my jaw there. We do our best, and try to learn every day. Wilder Hives, thanks for following. At runtime, several ways to get started monitoring application. It's a terrible accent, honestly, if you ask me. And I'm Dutch. At runtime, instrument and you can always hear it because a lot of Dutch people are also working with Microsoft. They have some prominent place in Microsoft as well. And when you hear them talk, I can immediately tell, like you did, that he is Dutch or indeed Belgium. For Belgium, it depends which side of Belgium you are in. One side is mostly French. But I think that's the same as with Canada, maybe. It's also French, English, like in a British colony. Let's quickly wrap some things up for this, because there's a break coming up. So start monitoring at runtime, development time, and development time is now, they are working on Aspire, for instance, that we discussed in the previous live streams, I think on Monday, last Friday, and Wednesday. Finally got it to work on Monday. But that's something that's also done on development time. Instrument your web pages for page view, Ajax and client side telemetry, analyze mobile app. That's probably using the monitoring with Maui, availability tests, ping your websites to see if they are still active. I think Azure also has a page like that to discover if it's still having issues or not. Discover log-based metrics. I think it's a good time here to put in a break. Let's see. What I wanted to do here is put in a dinner break. I think if everyone has joined me from the start, we're 4 hours in. I think 3, 4, 5, 6, 7. We have been running 4 hours now. Exactly 3 hours and 56 minutes is what I see on my clock. And my water is running out and my voice is getting dry and I need some food. Let's have a look. It's now 7 p.m. European time. That means that I will be putting a break in here. And I need to make that on screen as well. We say 8-hour marathon, renew AZ204. Now on dinner break. Be right back. And put a timer on that as well. Yeah, that should work. So I hope you will either subscribe to my channel on YouTube, Soft as in Software, youtube.com soft as in software. Or if you are on Twitch, and most of you are in Twitch already, make sure that you follow. If the stream breaks up, then you can always find me back. I will keep the stream running for the upcoming hour. Have a dinner break, so everyone can have some lunch or dinner or whatever. If you're in Eastern US, it's now 1 o'clock, so probably after lunch also already. And after lunch we are going to continue with where is it? This one with the list. We're now into the monitoring something, monitor app performance, and there's a couple more to go. So hopefully we can finish it all up today, but maybe not. At least I will try to do the certification after stream tonight, and otherwise continue next thing tomorrow again to wrap it up. For now, let's have a break, and let's put the chat on the screen there. Let's have a dinner break. Whatever break. Whatever break. Thanks for now, at least, and hope to see you back when the timer ends. There, it's counting back to 0, so you should see when it's starting again. Thanks for now for joining, and make sure you follow on YouTube or Twitch. Be right back. Bye bye. Welcome back. This is the 5th hour. Finished my dinner. Let's quickly go to the other screen there. So what we've been what have we been doing before the break? We have been going over the modules. Azure Functions, explore Azure Functions, develop Azure Functions, implement Azure defaults, implement Azure app configuration, and we are now at monitor app performance. And we are somewhere in the middle. So we're planning to do a couple more modules there. If you're still here, thanks for sticking around. Discover log metrics. Application Insight log metrics let you analyze the health of the monitoring apps. A little bit of a frog in my throat. 4-hour talking. Create powerful dashboards. Configure alerts. There are only two kinds of metrics. Log-based metrics behind the scene are translated into Gusto queries. Gusto query language. Storm events where start time between some date and can count that. The table. Okay. Standard metrics are stored in pre-aggregated time series. Since standard metrics are pre-aggregated during collection, they have better performance at query time. Standard metrics are a better choice for dashboarding, and real-time alerting. The log-based metrics have more dimensions, which makes the superior option for data analysis, ad hoc diagnostics. The namespace selector to switch between the log-based and the standard metrics in Metrics Explorer. Create a metric chart. Well, let's just continue here. Log-based metrics. Developers can use the SDK to send events manually by writing code that explicitly invokes the SDK, or they can rely on the automatic collection of events from the auto instrumentation. In either case, the Application Insight backend stores all the collected events as logs, and the Application Insight blades in the Azure portal act as an analytical diagnostic tool for visualizing events-based data from logs. Using logs to retain the complete set of events can bring great analytical and diagnostic value. For example, you can get an exact count of requests of a particular URL with the number of distinct users who made these calls. Or you can gather detailed diagnostic traces, including exceptions and dependency calls for any user session. Having the type of information can significantly improve visibility into the application health and usage, allowing to cut down the time necessary to diagnose issues with an app. At the same time, collecting a complete set of events might be impractical or even impossible for applications that generate a large volume of telemetry. For situations when the volumes of events is too high, Application Insight implements several telemetry volume reduction techniques, such as sampling and filtering that reduces the number of collected and stored events. Unfortunately, lowering the number of stored events are also lowers accuracy of the metrics that behind the scenes must perform query time aggregations of events stored in logs. Pre-aggregated metrics. The pre-aggregated metrics aren't stored as an individual event or with lots of properties. Instead, they are stored as pre-aggregated time series and only with key dimensions. This makes a new metric superior at query time. Retrieving the data happens faster and requires less compute power. This enables the new scenarios such as real-time alerting on dimensions of metrics, more responsive dashboards, and more. Both log-based and pre-aggregated metrics coexist in Application Insights. To differentiate between the two, in the Application Insights UX user interface, the pre-aggregated metrics are now called Standard Metrics Preview. The pre-aggregated are Standard Metrics Preview, while traditional metrics are log-based metrics. Let's make a copy of that for later reference, because I think that's an important part. The newer SDKs, Application Insights 2.7 and higher SDK, or later for .NET pre-aggregate metrics during collection. It applies to standard metrics sent by default, so the accuracy isn't affected by sampling or filtering. It also applies to custom metrics sent by getMetric, resulting in less data ingestion and lower cost. For the SDK that don't implement pre-aggregation, the Application Insights backend still populates new metrics aggregated by the event, aggregating the events received by the Application Insights event collection endpoint. While you don't benefit from the reduced volume of data transmitted over the wire, you can still use the pre-aggregated metrics and experience better performance and support of the near real-time dimensional alerting with SDKs that don't pre-aggregate metrics during collection. There's a bird whistling. It's worth mentioning that the collection endpoint pre-aggregates events before ingestion sampling, which means that ingestion sampling never affects the accuracy of the pre-aggregated metrics regardless of the SDK version you use with the application. Page 4. Instrument an app for monitoring. Application Insights is enabled through auto instrumentation agent or by adding the Application Insight SDK into your application code. Auto instrumentation is preferred instrumentation method. It requires no developer investment and eliminates future overhead related to the updating the SDK. It's also the only way to instrument an application in which you don't have access to the source code. In essence, you all have to do is enable, and in some cases configure the agent, which collects the telemetry automatically. The list of services supported by auto instrumentation changes rapidly. Visit this page for the list of what's currently supported. And we are usually on the .NET Core framework, but there's also the Java item. It's supporting functions, Spring Apps, Kubernetes, VM, Windows. Well, that's also on .NET and .NET Core. Standalone agent, any environment. Enabling via Application Insights SDKs, you only need to install the Application Insight SDK in the following circumstances. You require custom events and metrics. You require control over the flow or telemetry. Auto instrumentation isn't available, typically due to the language or platform limitations. To use the SDK, you install a small instrumentation package in your app and then instrument the web app, any background components and JavaScript within the web pages. The app and the components don't have to be hosted in Azure. The instrumentation monitors your app and directs the telemetry data into the Application Insights resource by using a unique token. The Application Insights SDKs for .NET, .NET Core, Java, Node.js, and JavaScript all support distributed tracing natively. Additionally, any technology can be tracked manually with a call to track dependency on the telemetry client. Track dependency. What you now see with Aspire is that they actually implemented the open telemetry option. Enable via open census. In addition to Application Insights SDKs, Application Insights also support distributed tracing through open census. Open census is an open source, vendor agnostic, single distribution of libraries to provide metrics collection and distributed tracing for services. It also enables the open source community to enable distributed tracing with popular technologies like Redis, Memcached, and MongoDB. Page number 5. Select an availability test. After you've deployed your web app or website, you can set up recurring tests to monitor availability and responsiveness of the application. Application Insight sends web requests to your application at regular intervals from the point around the world. It can alert if your application isn't responding or responds too slowly. You can set up availability tests for any HTTPS endpoint that's accessible from the public internet. What is it? Public internet, blah blah blah. Here you don't have to make any changes to the website you're testing. In fact, it doesn't even have to be the site that you own. You can test the availability of REST API that your service depends on. You can create up to 100 availability tests per Application Insights resource, and there are 3 types of availability tests. URL ping test, it's a classic. Create a test through the portal to validate whether an endpoint is responding and measure performance associated with that response. You can also set custom success criteria coupled with more advanced features like parsing dependent requests and allowing for retries. Standard test, preview. This single request test is similar to the URL ping test. It includes SSL, certificate validity, proactive lifetime check, HTTP request verb, for example get, head or post, customer headers and customer data associated with HTTP request. Custom track availability test. If you decide to create a custom application to run availability tests, you can use the track availability method to send the results to Application Insights. Note that multi-step test is a 4th type of availability test. However, that's only available through Visual Studio 2019. Custom track availability test is the long-term supported solution for multi-request or authentication test scenarios. And it's important, the URL ping test relies on the DNS infrastructure of the public internet to resolve the domain names of the tested endpoints. If you're using private DNS, you must ensure that public domain name servers can resolve every domain name of your test. When that's not possible, you can custom track you can use custom track availability tests instead. So if it's not in the public DNS, then you have to be routed back to the track availability test. That's custom. Next. Troubleshoot app performance by application map. Application map helps you spot performance bottlenecks and failure hotspots across all components of your distributed application. Each node on the map represents an application component or its dependencies and has the health KPI and alert status. You can click through from any component to the more detailed diagnostics such as application insights events. If your app uses Azure services, you can also click through the Azure diagnostics such as SQL Database Advisor recommendations. Components are independently deployable part of the distributed microservice application. Developers and operations teams can have code level visibility or access to telemetry generated by these application components. Components are different from observed external dependencies such as SQL, event hubs, etc., which your team or organization may not have access to code or telemetry. Components run on any number of server role container instances. Components can be separate application insights instrumentation keys, even if the subscriptions are different, or different roles reporting to a single application insights instrumentation key. The preview map experience shows the components regardless of how they are set up. You can see the full application topology across multiple levels or related application components. Components should be different application insights resources or different roles in a single resource. The app map finds components by following HTTP dependency calls made between servers with the application insights SDK installed. The experience starts with progressive discovery of the components. When you first load the application map, a set of queries is triggered to discover the components related to this component. A button at the top left corner updates with the number of components in your application as they were discovered. By clicking Update Map Components, the map is refreshed with all components discovered until that point. Depending on the complexity of your application, this may take some minutes to load. If all the components are roles within a single application insight resource, then this discovery step isn't required. The initial load of such an application has all its components. If you look at the picture here, like instance 1, availability things there, database, backend, queue, SQL blob. One of the key objectives with this experience is to be able to visualize complex topologies with hundreds of components. Click on any component to see the related insight and go to the performance and failure triage experience for that component. Application map uses the cloud role name property to identify the components on the map. You can manually set or override the cloud role name and change what gets displayed on the application map. Page number 7, knowledge check. Have a question for the chat room there. Check your knowledge. Which of the following availability tests is recommended for the authentication tests? Is that a URL ping? Is that a standard? Or is that a custom track availability? Question number 2 is which of the following metric collection types provides near real-time querying and alerting on dimensions of metrics and more responsive dashboards? Is that log-based? Is that pre-aggregated, or is it Azure Service Bus? Your time starts now. 30 seconds. And yeah. Usually it's also always one that's completely wrong. The remaining two are usually could be valid. So recommended for authentication tests. I think it's not URL ping because that's just checking if the URL is up. The standard test. I don't think that's using authentication. So my guess would be custom track availability. Which of the following metrics collections types near real-time querying and alerting dimensions of metrics and more responsive dashboards? I think that's the pre-aggregated one. I think Azure Service Bus completely wrong. Logs is the old one, but tends to be slow. Let's see what the answers are here. Okay, they're both right. Custom track availability test is a long-term supported solution for multi-request and or authentication test scenarios. I thought so, because how do you put your authentication in a default? Pre-aggregated metrics are stored as time series and only with key dimensions, which enable near real-time alerting on dimensions of metrics, more responsive dashboards. No, that did not copy. Copy that again. Yeah. Good. I think this was ready. Keep up the good work. So we finished this one as well. That's app performance. So the next one would be Azure Container Apps. The upcoming 5 items are actually things that I know the least about. Not much, not that much. I don't use containers that much. First time I installed Docker for desktop was like this week. So let's have a look at this. 40 minutes module. Need to take a sip of my coffee for that. So what are we learning? We are learning to describe the benefits of Azure container instances and how resources are grouped. Deploy a container instance in Azure by using Azure CLI. Start and stop container using policies. Set environment variables in container instances. Mount file shares in your container instances. Let's start here. That's basically the same as what we just did. Next, we have 9 pages on this. Explore Azure Container Apps. Azure Container Apps enable you to run microservices and containerized applications on a serverless platform that runs on top of your Azure Kubernetes service. Common uses for the Azure Container Apps include deploying API endpoints, hosting background processing applications, handling event-driven processing, running microservices. Application built on Azure Container Apps can dynamically scale based on HTTP traffic, event-driven processing, CPU or memory load, and CADA supported scaler. That's what we saw earlier today. This is the module implement containerized solutions. Implement Containerized solutions. It's a bit hot here in the room, but with Azure Container Apps, you can run multiple container revisions and manage container apps. Application lifecycle autoscale the apps based on CADA. Supported scale trigger. Most applications can scale down to 0. Applications that scale on CPU or memory load can't scale to 0. I think we saw this also with the Azure Functions. Enable HTTPS ingress without having to manage other Azure infrastructure, split traffic across multiple versions of an application of blue-green deployment, and A/B testing. Use internal ingress and service discovery for secure internal-only endpoints with the built-in DNS-based service discovery. Build microservices with Dapper. Dapper is the distributed application runtime. Run containers from any registry, public or private, including Docker. Including Docker Hub and Azure Container Registry, ACR. Use the Azure CLI extension, Azure Portal or ARM templates to manage your applications. Maybe Bicep is also on top of that these days. Provide an existing virtual network when creating an environment for your container apps. Securely manage secrets directly in your application and monitor logs for Azure Log Analytics. Azure Container Apps environment, including container apps, are deployed to a single container app environment, which acts as a secure boundary across around groups and container apps. Container apps in the same environment are deployed in the same virtual network and write logs to the same log analytics workspace. You may provide an existing virtual network when you create an environment. Reasons to deploy container apps to the same environment includes situations when you need to manage related services, deploy different applications to the same virtual network, including Dapper applications that communicate via the Dapper Service Invocation API, have applications that start raining again. Having applications to share the same Dapper configuration, have applications to share the same log analytics. Reasons to deploy container apps to different environments include situations where you want to ensure two applications never share the same compute resources and two Dapper applications can't communicate via the Dapper Service Invocation API. Microservices with Azure Container Apps. Microservice architectures allows you to independently develop, upgrade, version, and scale core areas of the functionality in an overall system. Azure Container Apps provides the foundation for deploying microservice feature, independent scaling, versioning, and upgrades, service discovery, native Dapper integration. Dapper integration, when you implement a system composed of microservices, function calls are spread across the network. To support the distributed, it's now going quite hard outside. To support the distributed nature of the microservices, you need to account for failure, retries, and timeouts. While container apps feature the building blocks for running microservices, use of Dapper provides even a richer microservice programming model. Dapper includes features like observability, PubSub, and service-to-service invocation with mutual TLS, retries, and more. Page number 3. Exercise to deploy a container app. In this exercise, you create a secure container app environment and deploy container app. Need an Azure account for this again. Hope my bill won't be charged too much for that because I'm almost running out of my Azure credits. Sign into the Azure portal and open the Cloud Shell. I think it's still available. Let's reconnect. So this resource group can go Azure 202, 2024, 05, 15.1, that can go now. Lead resource group. Copy that. Enter the resource group name to confirm deletion. Delete. Yeah. This one is already gone. Okay, so we're now in PowerShell, but we want to have a bash cloud shell. Apparently for the demo. Install Azure Container Apps extension for the CLI. Copy. Oh. That's not good. Copy that again. Plain text. Default enabled included preview versions for extension installation now disabled in May 2024. Use allow preview true to enable it specifically if needed. The installed extension container app is now preview. Excuse me. Register Microsoft app namespace. Copy that. Azure provider register namespace Microsoft.app. Registering is still ongoing. You can monitor as AZ providers show and Microsoft app. Azure Container App might have migrated from the Microsoft Web namespace to the Microsoft App namespace. Register Microsoft Operational Insights provider for the Azure Monitor Log Analytics workspace if you haven't used it before. Copy. Register namespace Microsoft Operational Insights. Registering the Microsoft App namespace in the Microsoft Operational Insights can take a few minutes to complete. Set environment variables used later in this exercise. Replace location with region near you. So that's this, and location would be West Europe. That's what we saw, I think. Copy. My resource group is something random. My location, West Europe. And container environment. Create a resource group for your container app. Copy. That creates a resource group called AZ204 app region. Don't see it yet, I think. It's this one. Yes, nothing in there now. That's good. So we now created a resource group where we can do things, create an environment. With CLI upgraded and new resource group available, you can create a container apps environment and deploy your container app. In the environment in the container app creates a resource security boundary around the group of containers. Container apps deployed to the same environment are deployed in the same virtual network and write logs to the same log analyzer. Create an environment by using the AZ container app environment create. Copy. Behavior of this command has been altered by the following extension: container app no log analytics workspace provided. Generating a log analytics workspace with the name workspace AZ204 app contribute something. There you are. That's the environment. Now create a container app. After the container app environment finishes deployment, you can deploy a container image to the Azure container apps. Still running. Deploy a sample app container image by using container app create. AZ container app create, name my container app, resource group, environment of the environment. We have an image, Microsoft Azure Docs Container Apps Hello World, latest version, target port 80, ingress is external, and query properties configuration ingress friendly, qualified domain name, FQDN. Is it ready yet? No. This one. still running. The question is, how long does that take? There it is. Container app created. After the container app environment finishes deployment, you can deploy container image. This was the environment creation. Now you have to copy this one. Deploy the app container image. Paste. That should create a container. I think. Deploy sample app container. By setting --ingress to external, you make the container app available for public requests. Commands returns a link to the access to access your app. Container app created. Access your thingy at something. Mango plant. Verify deployment. Select the link returned for the Azure app container and command verify the app is running. And welcome to Azure Container Apps. How cool is that? We have some lag on the system again. Not sure if that's related by running like 5 hours or more. Clean up resources. When no longer needed, you can use the AZ group delete command to remove the resource group, container app, and other resources stored here. Copy this and then go to there. Paste this plain text. Let's run that. Are you sure that I want to delete my resource group? It's running. Tearing it all down. Move to the next page here. That was only page 3. Exploring containers in Azure Container Apps. Azure Container Apps manages the details of Kubernetes and the container orchestration for you. Containers in Container Apps can use any runtime, programming language, or development stack of your choice. Containers for Azure Container App are grouped together in pods inside the revision snapshots. This is the environment. There we have the container app, what we put in there. And there's a revision 1 and revision 2. Same here. The Azure Container App support Linux-based x86 or 64 Linux AMD container image. There's no required base container, There is no required base container image, and if a container crashes, it automatically restarts. Configuration. The following code is an example of the containers array in the properties template section of the container app resource template. The excerpts shown some of the available configuration options when setting up the container when using the Azure Resource Manager, ARM templates, changes to the template the ARM configuration section trigger at the new container app revision, where we have containers with the environment and a secret, some resources, half CPU, 1 gig, volume mounts, and some probes there. Multiple containers. You can define multiple containers in a single container app to implement sidecar pattern. Multiple containers in a single container app. Sidecar pattern. Peripheral tasks such as platform abstraction, proxy to remote service logging configuration. Okay. The containers in a container app share hard disk, network resources, and experience the same application lifecycle. Examples of sidecar containers include an agent that reads logs from the primary app container on shared volume and forwards them a logging service to a logging service. A background process that refreshes the cache used by the primary app container in the shared volume. Running multiple containers in a single container app is an advanced use case in most situations where you want to run multiple containers, such as when implementing a microservice architecture. Deploy each service as a separate container app. Let's copy the note there. To run multiple containers in an app, add more than one container in the container array of the container app template. Container registries. You can deploy images hosted on private registries by providing credentials in the container app configuration. To use the container registry, you define the required fields in the registries array in the properties configuration section of the container app resource template. The password secret ref field identifies the name of the secret in the secrets array name where you define the password. With the registry information added, the saved credentials can be used to pull the container image from the private registry your app is deployed. Limitations. The Azure Container App has the following limitations. Privileged containers. Azure Containers App can't run privileged containers. If your program attempts to run a process that requires a root access, the application inside the container experiences a runtime error. I guess that's a security feature. Operating system. Linux-based container images are required. Number 5. Implement authentication and authorization in Azure Container Apps. Azure Container App provides built-in authentication authorization features to secure external ingress-enabled container apps with minimal or no code. The built-in authentication feature for container apps can save time, the effort, by providing out-of-the-box authentication with federated identity providers, allow you to focus on the rest of your application. Azure Container Apps provide access to various built-in authentication providers. The built-in authentication features don't require any particular language, SDK, security expertise, or even any code that you have to write. You basically have to know nothing. As with everything, just do it. This feature should only be used with HTTPS. Azure allow insecure is disabled on your container app ingress configuration. This feature should only be used with HTTPS. Ensure allow insecure is disabled on your container's app ingress configuration. You can configure your app container app for authentication with or without restricting access to your site, content, and APIs. To restrict app access only to authenticated users, set its restrict access setting to require authentication. To authenticate but not restrict access, set its restrict access setting to allow unauthenticated access. So that's basically anonymous, I guess. Identity providers. Container apps use a federated identity in which the third-party identity provider manages the user identity's authentication flow for you. The following identity providers are available by default. Microsoft Identity Platform, scaffolding probably in auth login AAD, auth login Facebook, auth login GitHub, auth login Google, auth login Twitter, although I doubt that's still available, I don't know. Okay, still use Twitter as authentication engine. Providers, I should say. Any OpenID Connect provider. When you use one of these providers, the sign-in endpoint is available for the user authentication token validation from the provider. You can provide your users with any number of these provider options. Feature architecture. The authentication and authorization middleware component is a feature of the platform that runs as a sidecar container on each replica in your application. When enabled, every incoming HTTP request passes through the security layer before being handled to your application. That's also the middleware from the .NET application. Platform middleware handles several things for your app, authenticates users and clients with the specified identity providers, manages the authenticated session, injects identity information into HTTP request headers. The authentication and authorization module runs as a separate container, isolated from your application code. As the security container doesn't run in process, no direct integration with the specific language frameworks is possible. However, relevant information your app needs is provided in these request headers. Authentication flow. The authentication flow is the same for all providers, but differs depending on whether you want to sign in with the provider SDKs. The sentence is a bit different. The authentication flow is the same for all providers, but differs depending on whether you want to sign in with the provider SDKs. If you log in without the provider SDKs, self-server directed flow or server flow, the application delegates federation sign-in to the container apps. Delegation is typically in the case with browser apps, which presents the provider sign-in page to the user. With provider SDK, client-directed flow or client flow, the application signs users into the provider manually and then submits the authentication token to the container app for validation. This approach is typically for browser-less apps that don't present the provider's sign-in page to the user. An example is a native mobile app that signs users in using the provider SDK. Next, page 6. We have to do something again here. Manage revisions and secrets in Azure. Azure Container Apps implements container app versioning by creating revisions. Revision is immutable snapshot of a container app version. You can use revisions to release new versions of your app or quickly refer to any version of your app. New revisions are created when you update your application with revision scopes changes. You can also update your container app based on specific revision. You can control which revisions are active, and the external traffic is routed through to each active revision. Revision names are used to identify revision and the revision's URL. You can customize the revision name by setting the revision suffix. By default, container apps create a unique revision name with suffix consisting of a semi-random string or alphanumeric characters. For example, for a container app named Album API, setting the revision suffix name to the first revision would create a revision with Album API first revision. You can set the revision suffix in the ARM template through the Azure CLI, Azure Container App Create, and AZ Container App Update commands, or when creating revision via the Azure portal. Updating your container app with the Azure Container App Update command, you can modify environment variables, compute resources, scale parameters, and deploy different images. If your container app updates includes revision scope changes, a new revision is generated. Azure Container App Update, the name, resource group, and the image. You can list all revisions associated with your container app with the AZ Container App Revision List commands. Azure Container App Revision List. Let's make a quick note there to remember it. And this is the update. Copy. Manage secrets in Azure Container Apps. Azure Container Apps allows your application to securely store sensitive configuration values. Once secrets are defined at the application level, secured values are available to container apps. Specifically, you can reference secured values inside scale rules. Secrets are scoped to an application outside of any specific revision of an application. Adding, removing, or changing secrets doesn't generate new revisions. Each application revision can reference one or more secrets. Multiple revisions can reference the same secrets. An update or deleted secret doesn't automatically affect existing revisions in your app. When the secret is updated or deleted, you can respond to changes in one of two ways: deploy a new revision or restart an existing revision. Before you delete a secret, deploy a new revision that no longer references the old secret. Then deactivate all revisions that reference the secret. Container Apps doesn't support Azure Key Vault integration. Instead, enable managed identity in the container app and use Key Vault SDK in your access secret. Defining secrets. When you create a container app, secrets are defined by using the secrets parameter. The parameter accepts a space-delimited set of name-value pairs. Each pair is delimited by a equal sign. In the example below, a connection string to a queue storage account is declared in the secrets parameter. The value of the queue connection string comes from an environment variable named connection string. After declaring secrets, there are secrets, and that's getting that from the environment variable. After declaring secrets in the application level, you can reference them in environment variables when you create a new revision in your container app. With an environment variable references when an environment variable references a secret, its value is populated with the value defined in the secret. To reference a secret in the environment variable in the Azure CLI, set its value to secret ref, followed by the name of the secret, as we see in here. After declaring the secrets at the application level, you can reference them in the account variables when you create a new revision in your container app. When an environment variable references a secret, its value is populated with value defined in the secret. To reference a secret in an environment variable in the Azure CLI, set its value to secret ref, followed by the name of the secret. That's the story. To follow example shows an application that declares a connection string at the application level. The connection string, this connection is referenced in a container environment variable. Page number 7. That's a big one. Big Explore Dapper distributed application runtime with Azure Container Apps. The distributed application runtime, Dapper, is a set of incremental adoptable features that simplify the authoring of distributed microservice-based applications. Dapper provides capabilities for enabling application intercommunication through messaging via pub/sub or reliable or secure service-to-service calls. Dapper is an open source cloud native computing foundation CNCF project. The CNCF is part of the Linux Foundation and provides support, oversight and direction for fast-growing cloud-native projects. As an alternative to deploying and managing the Dapper OSS project yourself, the Container App Platform provides a managed supported Dapper integration, handles Dapper version upgrades seamlessly, exposes simplified Dapper interaction model to increase developer productivity. Develop the Dapper APIs, service-to-service invocation, state management, publish and subscribe, bindings, actors, observability, and secrets. And that means the service-to-service invocation, discover services and perform reliability, direct service-to-service calls with automatic MTLS, authentication, and encryption. State management provides state management capabilities for transactions and CRUD operations. Create, read, update, and delete. Allows publisher and subscriber container apps to intercommunicate via intermediary message broker, PubSub. Trigger your application based on events, binding. Dapper actors are message driven. Single-threaded units of work designed to quickly scale, for example in burst-heavy workload situations. Send tracing information into an application inside backend and access secrets from your application code or reference secure values in your Dapper components. That's the secret part. The table covers the stable Dapper APIs. To learn more about using the Alpha APIs and features, visit limitations. Dapper integration with Azure Container Apps. contains the same pictures. The following example based on the PubSub API is used to illustrate core concepts related to Dapper in use in Azure Container Apps. You have the multiple container apps. You have Sidecar with DA Dapper D, and then we have component against the Azure Service Bus. So these are containers with Dapper enabled. Dapper is enabled on the container app level by configuring the Dapper arguments. These values apply to all revisions of a given container app when running in multiple revisions mode. Dapper is the fully managed Dapper API exposed to each container app through the Dapper sidecar. Dapper API can be invoked from your container app via the HTTPS, now HTTP or gRPC. The Dapper sidecar runs on HTTP port 3500, and the gRPC is 50,001. Dapper uses a modular design where functionality is delivered as a component. Dapper components are shared across multiple container apps. The Dapper app identifies provided in the scopes array dictate which Dapper enabled containers apps loads a given component at runtime. Dapper enablement, you can configure Dapper using various arguments and annotations. That's a big list. It's not something you want to memorize. Azure Container Apps provide 3 channels through which you can configure Dapper is Container App CLI, Infrastructure as Code, templates as in Bicep or ARM, or the Azure portal. Dapper components and scopes. Dapper uses a modular design where functionality is delivered as a component. The use of Dapper components is optional and dictated exclusively by the needs of your application. Dapper components in the container apps are environment level resources that can provide a pluggable abstraction model for connecting to supporting external services, can be shared across container apps and scoped to specific container apps, or can use Dapper secrets to securely retrieve configuration metadata. By default, all Dapper enabled container apps within the same environment load the full set of deployed components. To ensure components are loaded at runtime or by only the appropriate container app, application scopes should be used. Knowledge check. There we are again. Time for the chat room. Check your knowledge. Which of the following options is true? And I probably am going to make some mistakes here because this is not my expertise area at all. Which of the following options is true about the built-in authentication feature in Azure Container Apps? It can only be configured to restrict access to authenticated users. Don't think so. It allows for out-of-the-box authentication with federated identity providers. And it requires the use of specific language or SDK. What revision? Question number 2. What is a revision in Azure Container Apps? That's a dynamic snapshot of container app version, a version of a container app that is actively being used, or an immutable snapshot of a container app version. Check your answers. First, think about it. 30 seconds. $15 seconds. 0. So let me guess. It's allowed for out-of-the-box authentication with federated identity providers. I think like with Google or whatnot. What's a revision in Azure Container Apps? The dynamic snapshot of container app version. Version of container app that's actively being used. Or an immutable snapshot of a container app version. I would think the last one, but I'm not really sure. Let's check the answers. And they're both correct. Azure Container Apps provide built-in authentication authorization features for secure external ingress. Enabled container app with minimal code or no code. And a snapshot, a revision, is an immutable snapshot. That's a complete module. Keep up the great work. Great. I still have this one. No, that resource group is gone now. So this one probably also doesn't work anymore. Guess this will time out. Let's close it. Let's go back to the modules here. This is what we've just finished. 40 minutes. I think we took a little bit longer than that. That was this one. Now manage container app, container images in Azure Container Registry. We have 1, 2, 3, 4 modules to go. And it's now 9 p.m. Let's have a look. How long is this? 8 units, 31 minutes. Should be able to do that in a half hour. Do some exercises here. We are currently in 6 hours and 12 minutes. Still going strong. Learning objectives. Manage container images in Azure Container Registry. So what we are going to do here is explain the feature and benefits Azure Container Registry offers. Describe how Azure Container Registry tasks to be automated in builds and deployments. Explain the elements of a Docker file. Build and run an image in ACR by using CLI. What do we need for this? Familiar containers, concepts, terminology, and understanding cloud computing. Oh, let's go back here. Make that a new page. Same things, what we already did. Discover the Azure Container Registry using ACR services with your existing container development and deployment pipelines, or use the ACR Azure Container Registry tasks to build container images in Azure built on demand, or fully automated builds with triggers such as source code, commits, and base images. By the way, starting a new module here. Don't forget to subscribe if you are not already done so. So if the module breaks down, then we can start up again. You can still find me, get a notification. Use cases to pull images from Azure Container Registry, the various deployment targets, scalable orchestration systems, and manage containerized applications across clusters of hosts, including Kubernetes, DCOS, and Docker Swarm. Azure services that support building and running applications at scale, including Azure Kubernetes Service, AKS, App Service, Batch, Service Fabric, and others. Developers can also push container registry as part of container development workflow. For example, target the container registry from a continuous integration and delivery tools such as Azure Pipelines or Jenkins. Configure ACR tasks to automatically rebuild application images when their base image are updated, or automate image builds when your team commits code to a GitHub repository. Create multiple steps tasks to automate building, testing, and patching multiple container images in a parallel cloud. Azure Container Registry Services tiers, the Azure ACR tiers, is available in multiple service tiers. These tiers provide predictable pricing and several options for aligning the capacity and usage patterns of their private Docker registry in Azure. So you have the basic, the cost optimized entry point for developers learning about the Azure Container Registry. Basic registries have the programmatic capabilities as standard or premium, such as Microsoft Entry, authentication, integration, image deletion, and webhooks. However, the included storage and image throughput are most appropriate for lower usage scenarios. Standard registries offer the same capabilities as basic, with increased included storage and image throughput. Standard registries should satisfy the needs of most production scenarios, but you also have the premium registries, provided highest amount of the included storage and concurrent operations, enabling high volume scenarios. In addition to higher image throughput, premium adds features such as geo-replication for managing single registry across multiple regions, content trust for image tag signing, and private link with private endpoints to restrict access to the registry. Supported images and artifacts grouped in a repository. Each image is a read-only snapshot of the Docker-compatible container. Azure Container Registries can include both Windows and Linux images. In addition to Docker container images, Azure Container Registry source related content formats such as Helm charts and images built to the Open Container Initiative image format specification. Automated image builds use Azure Container Registry tasks, ACR tasks, to streamline building, testing, pushing, and deploying images to Azure. Copy. I should make a new page here. And this one is called Publish Container Image to Azure Container Registry. Configure build tasks to automate the container operating system and framework patching pipeline, and build images automatically when your team commits code to source control. Page 3. That's a small page. Basic, standard, and premium Azure Container Registry tiers benefit from advanced Azure storage features like encryption at rest for image data security. Encryption at rest. All container images in your registry are encrypted at rest, Azure automatically encrypts an image before storing it and decrypts it on the fly when you or your applications and services pull the image. Regional storage. Azure Container Regional Registry stores data in the region where the registry is created to help customers meet the residency and compliance requirements in all regions except Brazil, South and Southeast Asia. Azure may also store registry data in a paired region in the same geography. In the Brazil, South and Southeast Asian region, registry data is always confined into the region to accommodate the data residency requirements for those regions. If a regional outage occurs, the registry data may become unavailable and isn't automatically recovered. Customers who wish to have the registry data stored in multiple regions for better performance, different geographies, or who wish to have resiliency in the event of a regional outage should enable geo-replications. For the geo-replications, you need a premium thing, I think. Zone redundancy. Feature of the premium service tier, zone redundancy, uses Azure availability zones to replicate your registry to a minimum of your separated zones in each enabled region. Let's quickly go back. Premium registry provide the highest amount of storage, enabling high volume scenarios. In addition to higher impact, Premium adds features such as geo-replication for managing single registry across multiple regions, content trust for image tags, signing. So that's something different than the zones, I would think. But at least they mention zones in here. Scalable storage. Azure Container Registry allows you to create as many repositories, images, layers, or tags as you need, up to the registry store limit. What is the limit? That depends on your payment level. High numbers of repositories and tags can impact the performance of your registry. Periodically, delete unused repositories, tags, and images as part of your registry maintenance routine. Delete registry resources like repositories, images, tags can't be recovered after deletion. Build and manage containers with tasks. ACR Tasks is a suite of features within the Azure Container Registry. It provides cloud-based container image building for platforms including Linux, Windows, and Azure Resource Manager, and can automate operating systems and framework patching for Docker in Docker containers. The ACR tasks enable automated builds triggered by source code updates to the container-based images or timers. Task scenarios supports several scenarios to build and maintain container images and other artifacts. Quick tasks build and push a single container image to a container registry on demand in Azure without needing the local Docker engine installation. Think Docker build, Docker push in the cloud. This is what I kind of expected with the Aspire thing, where I needed to install Docker desktop, even though that AZD should do without Docker. Automatically triggered tasks enable one or more triggers to build an image. Trigger on source code update, trigger on base image update, trigger on a schedule. Multiple tasks extend the single image build and push capability of AZR tasks with multi-step, multi-container based workflows. Each ACR task has an associated source code context. The location of the set of sources used to build a container image or other artifact. Example contexts include Git repository or a local file system. Quick tasks. Before you commit your first line of code, ACR Tasks Quick Task feature can provide an integrated development experience by offloading your container image build to Azure. With Quick Tasks, you can verify that your automated build definition and catch potential problems prior to the committing of your code. Using the familiar Docker build format, the AZ build command in the Azure CLI takes a context, the set of files to build, sends it to the ACR tasks, and by default pushes the build image to a registry upon creation. Azure ACR build. Trigger tasks on source code update. Trigger a container image build or multi-step tasks when code is committed, or pull request is made or updated to Git repository in GitHub or Azure DevOps services. DevOps. For example, configure a build task with Azure CLI command ACR task create by creating a Git repository and optionally a branch and Docker file. When your team updates the code into a repository, an ACR task created webhook triggers a build of the container image defined in the repo. Triggers on base image update. So you can set up an ACR task to track the dependency of a base image which builds when it builds an application image. When the updated base image is pushed into the registry or a base image is updated in a public repo such as Docker Hub, ACR task can automatically build an application image based on it. Or you can schedule a task, optionally scheduling tasks by setting one or more times triggers when you create or update a task. Scheduling a task is useful for running container workloads on a defined schedule or running maintenance operations or tests on images pushed regularly to the registry. Then there is the multi-step tasks. Multi-step tasks defined in a YAML file. File that we all love and use. YAML files specify individual build and push operations for containers, container images or artifacts. They can also define execution of one or more containers, with each step using the container as its execution environment. For example, you can create a multi-step task that automates the following: build a web application, run the web application container, build the web application test image, run the web application test container which performs tests against the running application container. If the test passed, build a Helm chart archive package. Perform a Helm upgrade using the new Helm chart archive package. Image platforms. By default, ACR tasks build images on the Linux OS and the AMD 64 architecture. Specify the platform tag to build Windows images or the Linux images for other architectures. Specify the operating system and optionally a supported architecture in the OS architecture format. For example, --platform Linux /ARM. For ARM architectures, optionally specify a variant in operating system architecture variant format. For example, --platform Linux /ARM64/V8. If you look at this, the operating system is either Linux or Windows, and the architecture AMD 64, ARM64, or 386, or AMD 64. Next, page 5. Explore elements of a Docker file. A Docker file is a script that contains a series of instructions that are used to build a Docker image. Docker images are typically include the following information: the base or parent image we use to create a new image, commands to update the base OS and install other software, build artifacts to include, such as development application services to expose, such as storage and network configuration commands and to run when the container is launched. Create a Docker file. The first step to creating a Docker file is choosing a base image that serves the foundation for your application. For example, if you're building a .NET application, you might choose Microsoft.NET image as your base, where you see from Microsoft.com.NET runtime 6, working directory /app, copy the content to the published app, to the containers app directory, expose port 80, and then set the command to run that the container starts .NET on my app DLL. Let's go through each line. That's what we just did. This command sets the base image, sets the working directory, copies the contents to the app folder, expose the 80 port, and then the command will run when the container starts. We're not going to cover the Dockerfile specification. Visit the Dockerfile reference. If you want to study that a little bit more, then go ahead. Each of these steps creates a cached container image. As we build a final container image, these temporary images are layered on top of the previous and presented as a single image once all steps complete. Page 6. Exercise. Oh, we have an exercise again. Let's see if that's all running. Oh, my coffee is run out of coffee again. Talk too much. Let's do some things here. Exercise. Build and run a container image by using Azure Container Registry tasks. In this exercise, you use ACR to perform the following actions: create a container registry, build and push an image from a Docker file, verify the results, and run the image in ACR. We have already an Azure thingy there, and we are going to start bash there. Getting the hang of this by now. That is, if we have a portal there. Sign in there. Hopefully I'm not running out of resources yet. Bash. I think this is bash already, yes. Not this one. This one. Create an Azure Container Registry. Copy. Now we need this one again. And location will be West Europe. Copy. Plain text. Enter. That created a resource group. That's fairly quick. Now create a container registry. Copy. AZ204 ACR 2024 405 15 maybe. Let's see, Azure ACR create resource group. That should be the same as that one. And we're creating a basic registry. Copy. Paste plain text. Yo. Registry name must only be a lowercase. That's interesting. AZ204 ACR. Something like this. Copy. Plain text. That's good to know. So the registry name needs to be lower caps. Then this is what we did. The command creates a basic registry, cost optimized option for developers learning. As a container registry, build and push image from Docker file, copy. Plain text. Why is it echo? I don't think it should say echo. Oh, it's putting it in the Docker file variable there. That's the reason. And then we have to copy this from here to there. Then image sample hello version 1 registry. The registry is my container registry. That's this one. Copy. Copy. Paste plain text and enter. It's doing something. We have something running, I think. Run ID. This is what we did. Following is a shortened sample of the output of the previous commands, showing the last few lines. The result, you can see the repository field. The say hello image is listed. There you are. With a run there. Verify the results. Use the ACR repository list command to list the repositories. Replace my registry with the name again. Copy. Copy. Plain text. And enter. What do we get? Result sample hello world. It's in there. So far so good. Use the ACR repository show tags command to list the tags on the sample hello repository. Copy that again. To put the registry back again. I think this demo is created by someone else than the previous demos where the name was already put in the system. Copy, paste. V1, yeah. Excellent. Run the image in ACR, run the sample v1 container image by the ACR run command. We need to put in the name again. Copy. Copy. Paste plain text. And so this will do ACR run registry, the command registry sample hello world. Queued a run with ID. Something is running. Following parameter in this example runs the container blah blah blah. The following shortened output. That's with hello from Docker. There's the hello from Docker, and then we have a lot of information. It's good. When no longer needed, you can use the Azure group delete command. Copy. Paste plain text. And Azure group delete name AZ204 ACR. No, wait. Yes, we want to delete that. Module complete. Number 7, knowledge check. There we have a question for the chat room again. Check your knowledge. 2 questions. Which of the following Azure Container Registry options support geo-replication to manage single registry across multiple regions? Is it basic, standard, or premium? Single registry across multiple regions. Think about it. Which Azure Container, question number 2, which Azure Container Registry tiers benefit from encryption at rest? There we are. Put in your votes. Lock in your votes. 9 seconds to go. My guess would be premium for multi-geo. multiple regions. And Azure Container Registry, all, because that's part of the security policy. They're both correct. Premium is doing the multi-region. And obviously the security is applied to everything. It's the last page. Complete module. And we have another one down. Let's see, publish container thing. We have 3 left. Run container images. 31 minutes. I think that's what we already did, but we can try it again. Work with Azure Cosmos DB. I think that's kind of tricky because that requires your environment to be working. And I do remember that work environment was not working for that. Consume Azure Cosmos DB. $39. It's basically almost 3 hours. Well, let's do the container images and then have a little break. Then end up with the last 2. I stick with that. We are now like 6 hours and 46 minutes in. What are we going to do here? Describe the benefits of Azure container instances and allow resources to be grouped. Deploy a container instance in Azure by using Azure CLI, start and stop containers by added policies, set up environment variables, mount file shares in your container instances. Same thing. Next, 8 pages. There's a lot to read here. They say 3 minutes, but ACI, Azure Container Instances, is a great solution for any scenario that can operate in an isolated container, including simple application task automation and build jobs. Here are some benefits. Fast startup. ACI can start containers in Azure in seconds without the need to provision and manage VMs. Container access. ACI enables exposing your container groups directly to the internet with an IP, hypervisor level security. Isolate your application as completely as it would with a VM. Consumer data, customer data. The ACI services store the minimum customer data required to ensure the container groups are running as expected. Custom sizes. Provides optimum utilization by allowing exact specifications of the CPU, cores and memory. Persistent storage. Mount Azure files shares. Mount Azure file shares directly to the container to retrieve and persist state. Linux, Windows, just schedule both Windows and Linux container using the same API. For scenarios, you need full container orchestration, including service discovery across multiple containers, automatic scaling and coordinated application upgrades. For scenarios where you need full container orchestration, including service discovery, blah blah blah, then you need the Azure Kubernetes service. Container groups. The top level resource in Azure Container Instances is a container group. A container group is a collection of containers that get scheduled on the same host machine. The containers in a container group share a lifecycle, resources, local network, and storage volumes. It's similar to concept to a pod in Kubernetes. The following diagram shows the example of a container group that includes multiple containers. As a DNS name, my app East US, and then something Azure container with V1 and sidecar there. Oh, not sure what happened there. But mounted add data, app data, mounted add data logs. This example container group is scheduled on a single host machine, is assigned the DNS name, exposes a single public IP address and one exposed port. Consists of two containers, one container listens on port 80 and one listens on port 5000. Include two Azure file shares and volume mounts. And each container mounts one of the shares locally. Multi-container groups currently support only Linux containers. For Windows containers, Azure Container Instances only support deployment of a single instance. Deployment. There are two common ways to deploy a multi-container group. Use a resource manager template or a YAML file. Resource manager templates recommended. Resource manager templates recommended when you need to deploy more Azure services resources. For example, an Azure file share. When you deploy the container instances, due to the YAML format, more concise nature, a YAML file is recommended when your deployment includes only container instances. Resource allocation. Azure Container Instances allocates resources such as CPU, memory, and optional GPUs preview to a container group by adding the resources requests of the instances of the group. Using CPU resources as an example, if you create a container group with two instances, each requesting one CPU, then the container group is allocated 2 CPUs. Networking container group share an IP address and the port namespace on that IP address. This enables external clients to reach a container within a group. You must expose the port on the IP address and from the container. Because containers within the group share a port namespace, the port mapping isn't supporting. Containers within a group can reach each other via localhost on the ports that will be on the ports that they exposed, even if those ports aren't exposed externally on the group's IP address. Storage. You can specify external volumes to mount within a container group. You can map those volumes into a specific path. Supported volumes include Azure File Share, Secret, Empty Directory, or Cloned Repo. Common scenarios. A multi-container group are useful in cases where you want to divide a single functional task for a few container images. These images might be delivered by different teams and have separate resource requirements. Example usage include container serving a web application, a container pulling the latest content from the source control, an application container and logging container. The logging container collects the logs and metrics output by the main application and writes them to the log term storage. An application container and a monitor container. The monitor container periodically requests to the application to ensure that it's running and responding correctly, and raises an alert if it's not. A front-end container and a backend container. Front end and might serve as a web application with the backend running a service to retrieve data. Click next. Page 3. We have an exercise. Let's skip the first part where we have to create a bash. It creates a new resource group. Copy. Make this West Europe again. Copy. Notice this resource group is ACI. This creates a resource group. Succeeded. Create a container. You create a container by providing a name, a Docker image, and an Azure resource group to the Azure container create. That's basically what we did just before this. Copy. Set the label there. ACI example random. Run the Azure container create command to start a container instance to replace my location. Copy. Over here. The resource group is there. My container, Microsoft Hello World port, and the location should be West Europe again. Copy. Creates the container in ACI. Hi, Julian Velez1. Julian Velez1. How are you doing today? We are in our 7th hour of this marathon stream, where we are preparing for the AZ204 exam preparation. This one, because that's expired and we have to do some things to do. All these modules we have been doing: Azure Functions, Develop Azure Functions, Azure Key Vault, App Configuration, Monitoring, Azure Container Apps, Container Images in ACR, and now we are ACI. Working on that, and then after this 1.2 with Cosmos DB. Let's see if it's finished here. Oh. Make sure MSI is configured correctly. Get the request. Maybe we should restart this one. Maybe it was timed out. Nope. That's not what I wanted. To just drag this down a little bit. That's the one. And there's nothing in there yet. Still doing things here. Running out of budget. Where's the exercise here? Set this one again. That's not good. Let's close this and try it again. Let's also quickly go into my, that's my mic. Go into my budget. Let's see if I can up the budget a little bit. Putting it on secret right now, quickly. Credit remaining, 18 euros. Cost management. Billing. Budgets. Let's see if we have a budget there. Don't have budgets. Cost alerts. Nothing. Invoices. No. Question is, where can we put payments in if it's running out of? Forecast is still okay, but I'm not really sure. Let's guess, go back to the resource group and then enable your screen again. Resource groups. RCI, there we are. Enable screen again to bring you all back. Let's open the prompt there. Put that in my notes quickly. We now have a terminal. Again, exercise. Let's copy this. The DNS name. And then we have the container thing there. Run Azure container create command to start a container instance. Be sure to replace my location with a region you earlier specified. It should be okay. Is the label name correct? DNS name label? I think so. copy. Azure container, create resource group, and that's the resource group that we have here. AZ204 ACI RG, that's correct. Name my container. Microsoft Azure Docs ACI Hello World. It's running something. Drum roll. There we are. We have something running. I think it timed out on the token or something. So this is what we did now. Verify the containers running. Copy. Put that in here again. Azure containers show resource group, and then the resource group, then my name. Frequent. Go to table. I think there's nothing special in there. Copy. Plain text. And enter. There we have ACI example. Something different than this one because we are obviously in Western Europe. From a browser, navigate to the containers FQDN to see it running. You may get a warning that the site isn't safe. So that's basically this one. Copy. Welcome to Azure Container Instance, and it's even working. How's that? Excellent. So let's clean this up. Copy. Paste in plain text. And Azure group delete AZ204 ACRG. There we go. Release. Good. Next. Next. Run containerized tasks with restart options. The ease of speed of deploying containers in the Azure Container Instance provide a compelling platform for executing run once tasks like build, test, and image rendering. In a container instance, with a configurable restart policy, you can specify that the containers are stopped when their processes are complete. Because the container instances are built by the second, you are charged only for compute resources while the container executing your task is running. Container restart policy: when you create a container group in your Azure container instances, you can specify 3 start policies. As always, container in the container group are always restarted. This is the default setting, applies when there's no restart policy is specified. Never, containers in the container group are never restarted. Containers run at most once. Or on failure, containers in the container group are restarted only when the process executed in the container fails. When terminates with a non-zero exit code, the containers are run at least once. specify a restart policy. That means like Azure Container create with the restart policy on failure. Run to completion. Azure Container instances start a container and then stops it when its application or scripts exits. When Azure Container instances stops a container whose restart policy is never or on failure, container status is set to be terminated. Schwarzenegger. Set environment variables in container instance. Setting environment variable in your container instance allow you to provide dynamic configuration of the application script run by the config container. The environment variables are similar to the --n of command line argument to the Docker run. If you need to pass secrets as environment variables, Azure Container Instances support secure values for both Windows and Linux containers. In the following examples, the two variables are passed to the container when it's created. The example is assuming you're running CLI in the bash shell or cloud shell. If you use the Windows command prompt, specify the variables with double quotes, such as environment variables, and then something blah blah blah. Resource create, resource group, my container 2. Secure values. Objects with secure values and intended to hold sensitive information, like passwords or keys, are in your applications. Using the secure values for environment variables is both safer and more flexible than including it in your container image. You should never put it in your container image. Environment variables with secure values aren't visible in your container properties. Their values can be accessed only from within the container. For example, container properties viewed in the Azure portal at Azure CLI display only a secure variable name, not its value. Set a secure environment variable by specifying the secure value property instead of the regular value. This one. This is not a secret, and this is a secret. Two variables defined in the following YAML demonstrate the two variables. You would run the following command to deploy the container group with YAML. Azure Container create resource group and then the file secure environment YAML. Next. Let's quickly make a note of the name here. Copy. Mount an Azure file share in Azure Containers instances. 3 minutes. By default, Azure Container instances are stateless. If the container crashes or stops, all of its state is lost. The persistent state beyond the lifetime of the container, you must mount a volume from an external store. As shown in this unit, Azure Container Instances can mount an Azure file share created with Azure Files. Azure Files offers fully managed file shares in the cloud that are accessible via industry standard service message blocks protocol. Using an Azure file share with Azure Container Instances provided a file sharing feature similar to using Azure file share with Azure virtual machines. Limitations: you can only mount Azure file shares to Linux containers. Azure file share mount requires the Linux container as a root, run as root. And the Azure file shares mount are limited to CIFS support. Deploy container and mount volume. To mount an Azure file share as a volume in a container by using the Azure CLI, specify the share and the mount volume mount point when you create a container with AZ container create. AZ container create users group names hello files. That's the image, the DNS port. Then we have Azure file volume account name, storage key, share name, and the logs. The DNS name label must be unique within the Azure region where you create the container instance. Update the value in the preceding command if you receive a DNS name label error message when you execute the command. Deploy container and mount the volume. You can also deploy a container and mount the volume in a container with Azure CLI and YAML template. Deploying by YAML template is preferred method when deploying container groups consisting multiple containers. The following YAML template defines the container group with one container created ACI hello files image. The container mounts the Azure file share ACI share created previously as volume. Mount multiple volumes. To mount multiple volumes in a container instance, you must deploy using the RM template or the YAML file. To use the template or YAML file, provide the share details and define the volumes by populating a volumes array. In the properties section of the template. Property section. For example, this mounts the two volumes, my volume 1 and my volume 2, previously defined. All units complete. Next, knowledge check. There we are again. For the chat room, think about the two questions. Which of the following methods is recommended when deploying a multi-container group that includes only containers? Which of the following methods is recommended when deploying multi-container group that includes only containers? Second question, what is the purpose of the restart policy in Azure Containers instances? There we go, 30 seconds to think about it. Is that for question 1, Azure Resource Management Template, a YAML file, Azure Container Creates command? And the second question, to charge customers more for compute resources used while the container is running? To ensure containers are never restarted, even if the policy fails? Specify how, when and how containers should be restarted based on the desired behavior. Well, in this case, I think I should say YAML, and the second one I should say specify how containers should be restarted. And they are both correct. YAML is the ACI and the restart policy is to define if you want to restart or not, even if it has an error. By default, it will do it always. Complete module. Excellent. I think we have 2 to go. And these are based on Cosmos DB. meeting again. It should go back. I already did it in a new one. This will take 40 minutes according to this one. Work with Azure Cosmos DB. Let's quickly put in a coffee break. Let me see. That's like 22:30. 22:30. Okay, that's like 8 minutes for a quick visit to the restroom. And where's the screen there? Title editor. Restroom break. Okay, we have 7 minutes for the restroom break. Let's do that and be back in like 7 minutes. Don't forget to also subscribe. Welcome back. Everyone awake with the leader intro thing again? Let's go to the live coding window quickly, because we want to wrap up the last two modules here. How's everyone doing after 7.5 hours into the marathon? We have 2 modules to go. So the identity, what are we going to do here? Identify classes and methods used to create resources. Create resources by using Azure Cosmos DB. Write stored procedure triggers and user-defined functions by using JavaScript, our favorite language. What do we need for this? We should be familiar with development concepts, experience working with data solutions, an understanding of the cloud and computing, some experience with Azure Portal. I think we should be good with that. Let's go into that. First page will be the one that we already have been reading just now. It's always a repeat. Explore Microsoft.NET SDK version 3 for Azure Cosmos DB. The unit focuses on Azure Cosmos DB.NET version 3 for API NoSQL. Microsoft Azure Cosmos NuGet package. If you're familiar with the previous version of the .NET SDK, you may be used to terms collection and document. Azure Cosmos.NET version 3 GitHub repo includes the latest .NET samples repo solution. You use these solutions to perform CRUD, create, read and update and delete, and other common operations on Azure Cosmos DB. I had to turn the fan down. Because Azure Cosmos DB supports multiple API models, version 3 of the .NET SDK uses the generic term container and item. A container can be a collection, a graph, or a table. And an item can be a document, edge, vertex, or a row, and is the content inside a container. Below the examples showing some of the key operations that you should be familiar with. More examples, visit the GitHub link. Shown earlier. The examples below are all use the async version of the methods. Create a new Cosmos client with the connection string. Cosmos client is thread safe. It recommends it's recommended to maintain. I'm getting tired, so my speech is going downhill. It's recommended to maintain a single instance of Cosmos client per lifetime of the application. That enables efficient connection management and performance. Database example. So the database, create a database. The Cosmos client create database if not exist. Async checks if the database exists, and if it doesn't, it creates it. The only database ID is used to verify if there is an existing database. Read the database by ID. Database response, read response, database read async. Or delete a database, delete async. Container examples, the database create container if not exists. Async method checks if the container exists. And if it doesn't, it creates it. Only container ID is used to verify that's an existing container. Set throughput to the minimum value of 400 RU. This one. Container response, simple container, await database, create container if not exists. Get container by ID. There's the ID. delete container, ID, item examples, create an item, container, create item async. So that's inside a container. Method requires a JSON serializable object that must contain an ID property. Read an item, container read item async method. Method requires to serialize the item along with ID property, partition key, ID, account number, this is a partition key. Query an item, the container get item query iterator method creates a query for items under container in Azure Cosmos DB database using SQL statement with parameterized values. It uses a feed iterator. Put that in my notes. Let's start a new page here. Cosmos DB page 1. Feed iterator. Query definition queries new query select something blah 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 with parameter account input, and the account input that's and the partition key, I think. Feed iterator sales order result set container gets a query iterator sales order query request operations partition key account 1 maximum item count 1. Other resources, the Azure Cosmos.NET GitHub repo includes the latest .NET sample. But that's a lot. There's a lot of samples in here. Visit the article Azure Cosmos DB version 3 SDK examples for the SQL API for direct links specific examples. There's a different learn section there. Created the database basically is all the things that we just discussed in the document here as well. Page 3. That's a big one. That's a biggie. Exercise. In this exercise, you create a console app to perform the operations in Azure Cosmos DB. To connect to a Cosmos DB account, create a database, create a container, Azure account with an active subscription, Visual Studio Code, one of the support platforms, .NET 6, C# extension, I think I have that in place. Set up the following actions to prepare Azure, your local environment for exercise. Start Visual Studio Code. Let's close this. There's a lot of things in there. Directory 2024-05-15-2. CD 2024-05-15-2. Let's start clean here. Code. I should say code point dot. Let's close this. Code dot. That's now empty. Open a terminal window by selecting terminal on the top Then choose new terminal. New terminal. Sign into Azure by using the following command. Azure login. Oh. Still waiting for the command here. Login. I think we are already logged in. Web browser has been opened. Where? Oh, there. Let's quickly secrets here. Yeah. You've logged into Microsoft Azure. Announcements. Share the screen again. What does it say? As your CLI is collecting feedback, blah, blah, you may opt in to use WAM Web Account Manager by running the following. Okay. I think we're logged in now. Then create a resource group. Copy. That should be West Europe again. Europe. Copy. Yeah. Where's the exercise there? So we created a resource group now. Create the Azure Cosmos DB account. Replace my Cosmos DB account with a unique name to identify your Azure Cosmos DB account. The name can only contain lowercase, numbers, and hyphen characters. It must be between 3 and 31 characters. And probably needs to be unique as well. What's the name again? AZ204 AAF, that's me. 2024 054 15 today, yeah. Is that below 30? Yes, that's below 30. This command takes a couple of minutes to complete. Record the document endpoint shown in the JSON response. Document endpoint is used later in the exercise. Retrieve the primary key for the account by using the following command. Record primary master key from the command. Results will be used in the code. Copy that. And that means Cosmos DB account. Copy. And we need to get the document endpoint from the JSON. Prepare this one, set up the console application. Now that the needed resources are deployed to Azure, the next step is to set up the console application using the same terminal window. Yeah, we can do that only. Registration completed. We don't get any information yet. Still busy. It's a slow process apparently. Oh. Database account creation failed. Service unavailable. High demand. That's previous. I had the same thing last time as well. I think last year when we had to renew as well. Let's try it again. It's just too busy here. And what does it say? Database account. Something's failed provisioning state because the previous attempt to create was not successful. Please delete the previous instance before attempting to recreate the account. Database account is failed provisioning. And how do I delete that thing again? I can clean up the complete thing. Copy. Now I get to try to do the same thing again. We did log in, then we create the group. Copy. Make that 2 then. means we need to change that to 2 as well. This one should be 2 as well. Let's create now. And we create this one. Copy. That's the second step. That's the Cosmos DB account. In the meantime, what I can do is start the second part. Copy. Like so. Then .NET new console from there. We're going to build a new .NET console application. While this still tries to create the DB account. So maybe we should pick another region then. Now the question is, the location is that East US? Now let's try again once more. Copy, create a group in East US. It was created. Now try this. Copy. Create a new name with an X to region 3. Maybe East is better for this. Yeah, so I can imagine that it takes 40 minutes or more. program C from the Explorer pane. Build the console app. It's time to start adding packages. That needs to be done in a terminal again. Can also be done in here, I think. Still not created. Oh, now there we have it. And what did we need from that? Document endpoint. Document endpoint is this one. Copy. So that worked. Apparently it's very slow. Where's the exercise? Then retrieve the primary key. That's this one. Copy. Can't say this Cosmos DB is very performant. There we are. We have something there. Let's copy that. Retrieve the primary key for the account using the following commands. Record the primary master key from this one. That will be used in the code. This is what we did. Code our program. We did add packages there. Delete any existing code in the program CS. Add the using thing in there. Then copy, add the following code snippet after the using. Set copy. Oh, and I said paste. Then sure to replace the placeholder endpoint URI and primary key. The endpoint URI, that was this one. Copy. Primary key. This one. Is that all? Add the following code snippet. The code contains the class and add some error checking. Be sure to replace the place value for the endpoint URI in the primary key. These are warnings, I guess. Let's see if it can build. Oh, we need to put something else in here. Interesting. Copy. That needs to go in there. Apparently. Looks like there's a lot of things missing there. Create. Oh, we're not finished yet. So we need create database, copy, create database async. After Cosmos async, that's that one. Then create a database. Already had that. Create container. After create database. That's everything, I think. I format document. Everything's now okay, I think. Build. .NET build. Succeeded. Not sure why that's not working in Visual Code. Because it's PowerShell maybe. Let's try it running here. .NET run. operations. Create a database, create a container, end of program, press any key to exit. That did work properly. Not so much thanks to this one, but I think we need to clean up now. So this was working, clean up. This would be group 3, I think. Clean up group 3, yes. Copy that and then go. Oh, we can also do it here. Make that 3. Yes. So let's close this one as well. So everything should be cleaned up now. So if we go to resource groups and I do refresh, still have that one, but that's probably cleaning up. Let's close that. So back to the exercise here. That was finished. Next, create stored procedures. Azure Cosmos DB provides language integrated transactional execution of JavaScript that lets you write stored procedures, triggers, user-defined functions. To call a stored procedure trigger or user-defined function, you need to register it. For more information how to work with stored procedures in Cosmos DB, the unit focuses on stored procedures. The following unit covers triggers and user-defined functions. Writing stored procedures. Stored procedures can create, update, and read, query, and delete items inside an Azure Cosmos container. Stored procedures are registered per collection and can operate on any document or attachment currently present in that collection. Here's a simple stored procedure ID, serve script, function, blah blah blah, something. The context object, this one, provides access to all operations that can be formed by Azure Cosmos DB and access to request response objects. In case you use the response object to set the body of the response to be set, send back to the client, create an item using stored procedure. When create an item by using a stored procedure, oh, my coffee is getting cold. The item is inserted into Azure Cosmos DB container and an ID for a newly created item is returned. Creating an item is an asynchronous operation and depends on the JavaScript callback function. The callback function has 2 parameters, one for the error object and if in case it fails, the other one if case it is created. Inside the callback you can either handle the exception or throw an error. If callback is provided and there is an error, the Azure Cosmos DB runtime throws an error. The stored procedure also includes parameter to set the description as Boolean value when the parameter is set to true and the description is missing. The store procedure throws an exception, otherwise the rest of the store procedure continues to run. The store procedure takes as input document to create the body of the document to be created in the current collection. All such operations are asynchronous and depend on JavaScript functions callback. Let's create document, and then if it's failing or document created, if it's error, then throwing an error. Arrays as an input parameter for store procedure. When defined the store procedure in the Azure portal, input parameters will always send as a string to this store procedure. Even if you pass an array of strings as an input, the array is converted to a string and sent to the store procedure. To work around this, you can define a function within your store procedure to parse the string as an array. The following code shows how to parse a string input parameter as an array. So you get the array. If it's type string, then the array will be parsed JSON thing. Bounded execution. All Azure Cosmos DB operations must complete within the limited amount of time. Store procedures have a limited amount of time to run on the server. All collection functions return a Boolean function that represents if it was complete or not. Transactions within store procedures. You can implement transactions on items within a container by using a store procedure. JavaScript functions can implement a continuation-based model to batch or resume execution. The continuation value can be any value of your choice, and your application can then use this value to resume the transaction from the new starting point. The following diagram depicts how transaction continuation model can be used to repeat a server-side function until the function finishes its entire processed workload. So for each document, try to create, observe the return value. If it needs to go back until it's complete, then it's done. Page 5. Create triggers and user-defined functions. Azure Cosmos DB supports pre-triggers and post-triggers. Pre-triggers are executed before modifying a database item, and post-triggers are executed after modifying a database item. Triggers aren't automatically executed. They must be specified for each database operation where you want them to execute. After you define a trigger, you should register it by using the Azure Cosmos DB SDKs. For example of how to register and call a trigger, see pre-triggers and post-triggers. Let's have a quick look there. Outer on procedures, door procedures, pre-triggers. Pre-trigger, trigger ID. Following codes show how to call the pre-trigger. New item category, groceries, pick up strawberries is complete false. Then it goes to the document URI where the database container resides. Request options, and request options pre-trigger include, and then something there. And then we'll wait to create a document. Okay. For example, how triggers call triggers. Yeah, that's what we just want. I guess this is the same thing. The following example shows how the pre-trigger is used to validate the properties of an Azure Cosmos item that's being created. It adds a stamped property to a newly added item if it doesn't contain one. Validate to do item timestamp. That's the context, that's the request. Item to create is to get the body. If there's no timestamp in the item to create, it will create a timestamp and will add a timestamp. To update the body. Pre-triggers can't have any input parameters. The request object in the trigger is used to manipulate the request message associated with the operation. In the previous example, the pre-trigger is run when the creating of the Azure Cosmos item and the request message contains the item to be the JSON format. That's in the context. When triggers are registered, you can specify the operations it can run with. The trigger should be created with trigger operation value or of trigger operation create. With the trigger operation value of trigger operation create. Which means the trigger in replace operation isn't permitted. For example, how to register and call a pre-trigger. Visit pre-triggers article, that's what we just did. The post-trigger, the following example shows post-trigger creates queries a metadata item and updates it with details about the newly created item. So let's get the body again and then querying the metadata. Finds the metadata from the document. One thing that's important to note is transactional execution of triggers in Cosmos DB. The post trigger runs as part of the same transaction for the underlying item itself. An exception during the post trigger execution fails the whole transaction. Anything committed is rolled back and the exception is returned. User-defined functions. Following example creates a user-defined function to calculate income tax for the various income brackets. The user-defined functions would then be used inside a query. For the purpose of this example, assume there's a container called income with properties as follows. User1, user and income. The following is a function defined to calculate income. If the income is undefined, do nothing. If it's like 70,000, that should be 0.4 apparently. Page 6. Explore the change feed in Azure Cosmos DB. Change feed in Azure Cosmos DB is a persistent record of changes to a container in order they occur. Change feed support. That's a big part of text there. I think this is the last page for this module. Change feed supported the Azure Cosmos DB works by listening to an Azure Cosmos DB container for any changes. It then outputs the sorted list of documents that were changed in the order in which they are modified. Changes can be processed asynchronously and incrementally, and the output can be distributed across one or more consumers for parallel processing. Change feed and different operations. Today you see all inserts and updates in the change feed. You can't filter. That's today, as in software today. You can't filter the change feed for a specific operation. Currently, change feed doesn't log delete operations. As a workaround, you can add a soft marker on the items that are being deleted. For example, you can add an attribute called deleted, set its value to true, and then set the time to live value on the item. Setting the time to live ensures that the item is automatically deleted. Reading Azure Cosmos DB change feed. You can work with the Azure Cosmos DB change feed using either a push model or a pull model. With the push model, the change feed processor pushes work to a client that has been business logic for processing this work. However, the complexity in checking the work and storing state for the last processed work is handled within the change feed processor. With the pull model, the client has to pull the work from the server. The client, in this case, not only the business logic for the processing work, but also the storing state for the last process work, handles load balancing across multiple clients processing work in parallel and handles the error. Note that it's recommended to use the push model because you won't need to worry about polling the change feed for future changes, storing state for the last process change and other benefits. Most scenarios that use the Azure Cosmos DB change feed use one of the push model options. However, here are some scenarios where you may want to the additional low level control of pull model, reading changes from a particular partition key, controlling the pace at which your client receives the changes, doing a one-time read of the existing data in the change feed. So that's one time, not constantly. Reading change feed with the push model. There are two ways you can read from the change feed with the push model. There's your functions Azure Cosmos DB triggers and the change feed processor library. The Azure functions uses change feed processor behind the scenes, so there are both similar ways to read the change feed. Basically, the Azure functions are a layer on top of it. Azure Functions uses the change feed processor behind the scenes. That's what I said already. It automatically parallelizes change processing across container partitions. Azure Functions. You can create small reactive Azure functions that will be automatically triggered. And now we're back to module 1. On each new event in Azure Cosmos DB container change feed with the Azure Functions trigger for Azure Cosmos DB, you can use the change feed processor scaling and reliability event detection functionality without the need to maintain any worker infrastructure. Change feed processor. The change feed processor is the part of the Cosmos DB and Java v4 SDK. It simplifies the process of reading the change feed and distributes the event processing across multiple consumers as effectively. You can notice that we are in 8 hours and 23 minutes already because starting to stutter here. There are 4 main components in the implementing of the change feed processor. The monitoring container, monitored container. The monitored container has the data from which the change feed is generated. Any inserts and updates from the monitored container are reflected in the change feed container of the change feed of the container. The release container acts as a state of storage and coordinates processing the change feed across multiple workers. The release container can be stored in the same account as the monitored container or in the separate account. The compute instance hosts the change feed processor to listen for changes. Depending on the platform, it could be represented by the VM. a Kubernetes pod, an Azure App Service instance, an actual physical machine. It has a unique identifier referenced as the instance name throughout the article. So you have the four main components are the monitored container, release container, compute instance, and the delegate. The delegate is the code that defines what you, the developer, want to do with each batch of changes that the change feed processor reads. When implementing the change feed processor, the point of entry is always the monitored container from the container instance you call get change feed processor builder. That's the database name, container name, release container, release container, get container, change feed processor is from the get container, database name source container. This one, source container name. So you have the release container name, the source container name, get change feed processor builder to do item, and that's async with instance console host with release container that's built, starting change feed processor, await change feed processor, and that's returned. So you have the monitored container, that's this one. Now this is the release container. This is the source one. So you get this change feed processor on the source. With release container, where the first parameter is a distinct name that describes the goal of the processor, and the second name is the delegate implementation that will handle the changes. Following example of the delegate, handle change async. That's part of this one. That's on the get change processor builder. The feed, change feed sample. And the delegate. The delegate receives batch of changes were generated. The change to the feed. Start handling changes. Change feed consumed token. Change feed longer than expected for each of these items. Afterward, you define the compute instance name of the unique identifier with instance name. This one. This should be unique and different in each compute instance where deployed, and finally with the container to maintain the release state with release container. Calling build gives you the processor instance that you start with start async. The normal life cycle of the host instances is read the change feed. If there are no changes, sleep for predefined amount of time. And then go to number 1. If there are changes, send them to the delegate. If the delegate finishes processing successfully, update the leaf store with the latest processed point in time and go to 1. Sounds logic. Knowledge check. When defining a stored procedure in the Azure portal, input parameters are always sent. That we have to query again for the chat. 2 questions. When define a stored procedure, to see if you're still awake here. In the Azure portal, input parameters are always sent to as what type to the stored procedure. Is that a string, an integer, or a boolean? Question number 2. Which of the following would one use to validate properties? To validate the properties of an item being created. Is that a pre-trigger, post-trigger, or a UDF, user-defined function? You have 60 seconds, 30 seconds to go. Seventeen seconds. Three, 2, 1. I think the type is always a string, and the properties validate after being created, on being created. I think the post trigger. Pre-trigger is doing it before it's creating. Post trigger is after it's created. Check answers. Oh wow, that's that's an error. Responding in Dutch here. So the first one is right. When defined the store procedure in Azure portal, input parameters are always sent as a string. I think that was not too difficult. But the other one, it says incorrect. Post triggers run after that. No, that's what I was saying. Which of the following one would use to validate properties of an item? It's kind of tricky wording there. Being created, so this still needs to be created. So this is pre-trigger. So you have to properly read, apparently, as always. My explanation was correct, but he was not matching the question there. Complete module. Keep up the great work. We have one more module to go. We already like half an hour over the marathon time. Consume an Azure Cosmos DB for NoSQL change feed using the SDK. 40 minutes as well. Create a change feed processor and author a delegate to handle a batch of changes in client-side application. Last part. Then we're going to wrap up the stream. And then I'm going to do the renewal test. See if I can complete it with what we did today. Change feed features in the SDK. This is what we have seen in the previous one as well. I'm not going to repeat that. Implement and delegate for a change feed. There's handle change async. That's the handler. It's exactly the same as what we just have been looking at. Once that's created, you can create a new variable change handler, and that will be used as part of the process. So this is the change handler. Within the delegates, you can iterate over each item. That's what we saw in the previous one as well. Detected operation. Implemented change feed processor. Change feed processor is created in a few steps. So we have the source container. And we have the release container. Next, you can use the change feed process builder that's on the source container with the delegate in there. The builder ships with a series of fluent models methods to configure the processor with that included but not limited to. A method description with instance name, with start time, with release container, with no notification, with max items, with poll interval. Simple example would be to configure the instance name with instance name, release container using with release container, and then build the change feed processor. There's the with instance name. The resulting change for the feed processor includes both start async and stop async methods. Next, implement the change feed estimator. As the change feed processor handles changes, it functions as a time-based pointer. The pointer moves forward in time across the change feed and sends batches of changes to the delegate to run business logic. The change feed processor can potentially be constrained to physical resources on the host application. If so, they almost immediately assume that the change feed processor should be scaled out across multiple hosts, all reading from the change feed concurrently. However, identifying if the change feed solution needs to scale out can be difficult and requires an estimator feature. The change feed estimator is a sidecar function to the processor that measures the number of changes that are pending to be read by the processor at any point in time. To implement the estimator, you must first analyze the processor. In the example, the processor created with a specific release container and the delegate to handle changes. So they have the source container, release container, and then with the source container you get the change feed processor build thing on the product item processor, where the delegate is this one. That's in here. And that's doing something. Next you should be implemented the delegate, yeah. Finally, you build the estimator in a manner similar to the processor reusing the same release container. That's also an delegate. Exercise. Sorry, the lab environment needed to complete the exercises is temporarily unavailable, so we can't finish this. Well, that's too bad. Well, my guess is that's doing this exact same thing as we have just been reading. No, the virtual machine container, maybe we should refresh it. Let's see. unavailable. The virtual machine containing the client tools is need to provide it along with the exercise instructions. Use the button above to open the VM, but there is no VM. Limited number of concurrent sessions are available. If the hosted environment is unavailable, try again later. Alternatively, if you would like to use the development environment on your own computer, you can use this setup guide and follow the exercise instructions. Windows, Edge, .NET, PowerShell, Terminal. I think we have that all available, but we don't have the emulator. Yeah, so that's not going to work. Well, that's easy, and we are quickly done here. Knowledge check. There we go again. For the chat, final questions. Which method of container class is used to create a new change feed sim estimator? Oh, no, I'm not selecting anything here. Is that get change feed processor builder, get change feed estimator builder, get change feed iterator, or is second question, which method of the change feed processor class should you invoke to start consuming changes from the change feed? Which methods of the change feed processor class should be used? To invoke this, to start info, yeah. Is that get change feed processor builder, start async, or build? Throw in this 30 seconds. Almost there, 8 seconds. Right, my guess is that it's get change feed processor builder and it's built. And it's both incorrect. Let's have a look, because it's about the estimator. It's what I guessed, but I was thinking it was a trick question. And the get change estimator builder method. So let's go back in here. That's the one. This is the change feed. And this is the estimator builder. But the other one, I wonder why that's incorrect. I said build. This is incorrect. This method is invoked at the end of the building change and isn't a method of the change feed processor. So the start async is part of the change feed processor. Let's have a look again. Let's go further back. Actually don't see starting thing. Let's go to the explanation again. Because this one is the builder, change process builder with the delegate. Want to move forward. Get container, change feed production thing. Let's lease container. I don't see the thing there at all. It's not in here either. There's the build. There it is. Asynchronously invoke the start async. So there the processor, yeah, that's the thing, but it's not showing in the documentation at all in here. It's just showing the build thing. But it's never showing that it's the start async thing. That's in the exercise, start async. So the answer should be change feed estimator, builder, and start async. And this is tricky because it's not showing in the documentation at all. Well, that's tricky. Well, we can't do the exercise, sadly enough. The benefit, obviously, that we are now within the 9 hours and we are ready with everything. Let's close all these things there. So what did we do here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 modules. We've been processing 10 modules in 8 hours and 47 minutes. Not completely true because we also had 1 hour of dinner in the middle. So let's say 7 hours and 47 minutes. And we had a 5-minute coffee break, obviously. But I think we made it. All the way to the end. Don't save, let's clean up a little bit here. This is this one. This is what we are going to do. Offline though. Resource groups. I will check that after the stream is complete. And why is now my light going out? Because it's too late already. Great. Let's go to the main window there. So we are wrapping up. We started at 3 p.m. European time. That's like 9 a.m. Eastern EST. We've been doing a marathon of almost 9 hours, preparing the Azure 204 renewal plan. And I think we should be now ready to do that. So I'm going to wrap up today. This I probably won't publish the full stream here to YouTube. It will probably be on Twitch. But if you want to follow my other videos or live streams, usually a lot shorter, like 3 times a week of an hour, maybe 2 hours before I start working, hit the bell, subscribe, hit the bell, or if you're on Twitch, make sure you follow or subscribe or whatever. Send me all your money, obviously, because I want to be rich. Yeah, I'm a bit tired now, and I think I'm going to do the same thing in about like 3 months, because I actually like doing this marathon. It was a kind of trial and error, this, to see if this was working or not. A lot of reading. I don't have much left of my voice. Thanks for watching, everyone, and I hope to see you back in one of my follow-up streams. Next week I will be a week on holiday, so no streaming next week, and also not on Friday. I will be back, I think May will be the next stream. I think May 27 is probably my next stream. So thanks for watching, everyone, and hope to see you next time. Bye bye.